Welcome everyone to BlazorDay. I'm so excited to have you here today. My name is Laurent Bugnon. I work for Microsoft, and today with my friends and colleagues, Denis Voituron from Microsoft, Christophe Peunier, and Adrien Clairbois, who are Microsoft's most valuable professional, we prepared a whole day of sessions and with amazing speakers from Microsoft, but also speakers from the community, people who are like me and you, really passionate about tech, passionate about Blazor, and who wants to basically share this passion with you. We are going to start with Dan in just a moment. But after that, we also have tons of people who are going to speak to you today. So, you know, the first time I heard about Blazor, I thought to myself, okay, this is really cool tech, .NET running in the web browser. It's cool, but I felt also we kind of did that before. But the nice thing really with Blazor is the maturity and the fact that it's based on standards. So you can create client-server applications, for example, running on ASP.NET Server. You can also create pure client applications running .NET directly in the web browser based on WebAssembly, which is a standard, and that's really, really exciting. So today we are joined by Dan Ross. Dan, you are based in Seattle, and you are working on the Blazor team, and you were in Blazor pretty much from the start. How are you doing, my friend?
I'm doing great. It's great to be here. Happy Blazor Day. Thanks for having me on the show.
Happy Blazor Day is really true. And by the way, I noticed that some drawings on the walls are missing. I think there were some drawings earlier on. No?
Yeah, that was from the original Blazor Day when we did this the first time. My wife and kids made a whole bunch of hand drawings about Blazor, and sort of cheering me on and celebrating the Blazor releases that we had done recently, and they had put them all up on my back wall. I had them on there for a good long time. My wife made a bunch of them, and at one point she's like, Dan, it would be okay if you took those down now. So I did. But I still have them. I still have them in a drawer someplace. They're special.
Yeah. Memories are really special. That's great. So then I hear that you have a great demo to show us. I'm really excited to see it. But before we go into that, I would love to hear and maybe to speak a little bit more about the past. Like maybe you can tell us, you were there really from the start. Where did the idea of Blazor come from? And I'm also curious about the name Blazor. Can you tell us more about that?
Yeah, sure. I mean, we built Blazor really to empower web developers to be able to build rich, interactive, modern web apps using .NET, using C#. We wanted to bring the productivity and the performance and the safety of .NET to the browser, and doing it in a way that was consistent with open web standards, with the open web. Mm-hmm. And yeah, we've come a long way. We first shipped Blazor as a stable release back in like .NET Core 3.0, like I think it was 2019 when we shipped that first stable release. And it's come a long way since then. Like Blazor now supports the full flexibility of different web app rendering modes. Like we support static server-side rendering, like a traditional web app, and also the interactive render modes for doing it interactive rendering from the server, like over a WebSocket connection, or using WebAssembly directly from the browser, client side in the browser. It's really where we're focusing now our time and energy on the ASP.NET Core team. It's our recommended way to build web UI using the .NET platform.
Yeah, that's amazing. And in fact, we will have also a session a little bit later about the different rendering mode and all that. So quite excited to see that. When we were talking before the show started, I was telling you, every time I talk to you, I feel that, oh my God, I have so much to learn, right? Because Blazor is really full of new stuff every time. And in fact, we have .NET 10 around the corner, right? Very soon. But maybe just you kind of skip the question. Where does the name come from, Blazor?
Yeah, so the name is interesting. Like, well, Blazor is based off of an HTML templating language called Razor, which has been around for a while. We've used that in older .NET Web UI platforms like MVC and Razor Pages, and still used in those frameworks. Razor is a really natural mix of HTML and C# for defining the rendering logic. And then Blazor was also designed to work, in a browser, using WebAssembly, the latest open web standards. So browser plus Razor equals Blazor, I guess.
Blazor, I guess.
Steve Sanderson actually came up with the name originally. And you might wonder, well, why is it Blazor and not like Bazor or Brazor or something? And I think someone asked him that at one point, and he said, well, because of blockchain, of course. And I'm pretty sure he was joking at the time. I think later when we asked him, he said the L the L just made it sound better. You know, it just made it.
Blazor doesn't sound too. I like Blazor. It's pretty cool. Now this is awesome, really, and Blazor is really a web tech. You can also integrate with other frameworks, right? Angular, React, etc. This is also something that we can talk about a little bit if you want.
It's just open web, so you could. I mean, a Blazor app, you can kind of think of it as just a fancy JavaScript app if you squint at it. Like you're booting up some JavaScript, which then boots up a .NET runtime that's implemented in WebAssembly or sets up that connection to the server. So you can absolutely use Blazor with other open web technologies. If you want to render a Blazor component from your React app, you can do that. Like we support rendering custom HTML elements, Blazor components as custom HTML elements, and vice versa. Like you can use JavaScript libraries and components in your Blazor apps if you want to. We have JavaScript interop support, so it works with the full open web ecosystem.
No, the interrupt support is really good. I use that a lot also when I want to just tap into JavaScript, directly in the browser, maybe modify the DOM or do stuff like that, right? Which is really cool. No, this is great. Yeah. So personally, I use Blazor a lot as a WebAssembly. I like to have pure client tech, and then I like to have an Azure function on the server, which is of course costing me only pennies, right? Because it's really cheap to run. And usually I deploy my Blazor applications as a static web app on Azure because I'm a true Azure passionate. But obviously you don't have to, right? It's just basically a pure client web component that you deploy anywhere you want, and this is running great. So I want to go into the future now, and of course .NET 10 is around the corner, right? And we know that now you have a model where you release a new version of .NET every year, always in November, right? So the next .NET Conf is beginning of November. I can't remember the exact date. I believe it's November 10 or something like that.
11th to the 13th, coming up.
Sure. Coming up, yeah. All right, but anyway, coming up around the corner. And of course, Blazor is part of .NET, and so you will have also some new things. So what can you tell us about what's coming up?
So we have a lot of great stuff coming to all of ASP.NET Core, including Blazor and the .NET 10 release. For .NET 10, we're really focusing on 4 main focus areas. And if we could bring up my screen, I'll share a few thoughts on these high-level areas. So these are the 4 areas we've really been investing in for .NET 10. First is security. Security is obviously more important than ever before. And we want to make sure that it's easy for you to build secure web applications using the .NET stack. App observability and diagnostics. We want to make sure it's easy for you to monitor and troubleshoot your production applications. So we've really been working on adding more logging, more metrics, more tracing to the platform. Performance is always important. Every release, we want to make sure it's the fastest release of .NET ever, and that's true again for .NET 10. So we've made performance improvements across the stack for faster load times, faster runtime performance, including for the .NET WebAssembly runtime, lower memory usage. And then lastly, we really wanted to take the time this release to address those top pain points and feature gaps in the stack. Those things that maybe today have been like rough edges in the development experience. We really want to polish those up, make the development experience with ASP.NET Core and Blazor and 10 a delightful experience. So I can show you actually a few things. Go ahead.
Yeah, I would love that. And by the way, .NET 10 is going to be that's the next version, which is going to be long-term support, right? So .NET 10 is really a major evolutionary step in .NET. And if people start using it, then they are guaranteed to have support for a long time, and every second version is long-term support versus short-term support, right? So .NET 10 is really an important step here.
This is the next LTS release, long-term support release of the platform. It's a full 3 years of support. That's correct.
Yeah. Okay. So show us your demo then.
All right. Here I have. This is my machine. I've already installed the latest Visual Studio Insiders Edition. This is Visual Studio 2026 that just came out recently, and this is the fastest Visual Studio we've ever shipped. It's got a beautiful new UI. Let me go ahead and I'm going to create a Blazor web app using Visual Studio. So Blazor web app.
And to be clear, that's available to the community who is part of the Insider program, right?
Yeah, with anyone who wants to get access to the Insider release, you can do it. You can think of it as like what we used to have with the old preview channel. Now it's like it's more like the Visual Studio Code model. There's now an Insiders channel that you can install, and you get regular updates as we evolve the platform. You can install it side by side with your existing Visual Studio stable release. They work perfectly fine together. All right, so let's do a Blazor in .NET 10 demo. You can see I'm picking here .NET 10. It comes included with Visual Studio 2026 Insiders. I'm going to go ahead and add authentication to this because I want to show you some of the new security features, and we'll go ahead and create that. And then take a look at what's new in the latest version of the Blazor web app template. Visual Studio, go ahead and create this. All right, there we go. Okay, so you can see you got a really awesome new look and feel in Visual Studio 2026. There's all a bunch of new themes. I think this one's called Juicy Plum. You can pick whichever one you want. It's got AI features built in, like GitHub Copilot, and it's really built for performance. Now, with this new Blazor web app template in .NET 10, there's a couple new things that I wanted to just point out really quick. Like if we go in here into the let's go into the pages folder. You can see that there's now a not found page that's included with the Blazor web app template. We now have proper first-class support for returning, for handling not found responses in the stack. Like this will just render this page whenever you have a page that the router can't find. Like you can see this is wired up in the Blazor router. Like right here, there's this new not found page parameter on the router component where you just specify what page you want to use. So that will pick up my not found page. Also, it integrates seamlessly with ASP.NET Core's built-in support for handling status codes. Like if we scroll down here, you can see in the template also, we are now using the standard ASP.NET Core status code middleware so that if anywhere in my ASP.NET Core app it triggers a 404, it will render my Blazor not found page. So that's all first class. There's also an API even on Navigation Manager. Like if you want to trigger a not found, like someone tries to browse to an entity that doesn't exist or tries to edit something in the database that doesn't exist, you can trigger a 404 programmatically as well. So that's the new not found support. There's also up here in the layout, you can see there's also this new reconnect modal component that we include in the template. I used for when I created this project, I used the interactive server render mode instead of WebAssembly, which means I'm using that WebSocket connection pattern. It's sort of a remote rendering model with the browser. If that connection gets disconnected, there's a default UI that Blazor will present. But if you want to customize the reconnection UI, you can now do so using the reconnect modal component that's just right there in the template. You could do this before.
Maybe just for people who are very new to Blazor, right? This interactive render mode means that most of the page is loaded, and then you change just small portions of the UI dynamically from the server using a WebSocket connection, right?
Yeah, that's right. Like for this counter component is just a very simple button that you click and the count goes up. You can see up above here that this is using the interactive server rendering. So this is the one part of my app that's like setting up a connection with the browser so it can handle UI events and do really interactive rendering. The rest of the app is actually just using traditional static server-side rendering. So it's stateless, scales and performs really, really well. You can just add the render modes where you want to use them. So just to show you that those things are working, I'm going to add a little, let's make some edits here. I'll add like an emoji to the not found page, a little hourglass, and then the reconnect modal. Let's add like when we were trying to rejoin the server, if we try to reconnect when, like if the server goes down or whatever, let's add a little phone emoji there. Okay, let's get this going to see what the app actually looks like. While that's running, you may have noticed above, I opened this as well, is that in the identity section of the app where we're setting up authentication and ASP.NET Core identity, we now have support for passkeys in the stack. So you can use a phishing resistant, really safe way of logging into your website. Right,
oh, very nice, because we are moving away from passwords even within Microsoft, right? More and more passkey, Windows Hello, and now passkeys in Blazor. This is really cool.
That's right. Yeah. So passwordless authentication, much safer, much easier for your users to use. So if I try to browse to a not found page now, like I just browse to /foo, which is not a page in my app. You can see I get the not found page, and there's the the hourglass that the magnifying glass that I added to the page. Similarly, if I go to the counter, which is that interactive page, and then if I go back to the app and let's say I just shut down the app, so the server is no longer there to provide the interactivity. There's that custom reconnection UI. You can see it's trying to reconnect the server. You can see I've customized it a bit. If I restart the application so that it's now running again, then we're back up and running, and we're able to connect to the counter. Okay, so that's not found. That's the reconnection modal. For the passkey support, I'll show you that. We can now, on the login page, you see that there is a link to log in with a passkey. Before I can do
Okay.
that, I need to register a user. So let me go ahead and set up a user account on my app with a password that is just easy for me to type, and register that. And now when I register this user, the database hasn't been set up yet. So it's going to want to run a migration using Entity Framework Core to just set up the database schema for storing the users and their passwords. So that's what this page is just saying, hey, you need to run a migration to set up the database. So I'll go ahead and do that.
Okay.
You see the SQL just scrolled in the background. And so now if we refresh, we've registered our user. This is where you like confirm your email address for your account. Normally in a production app, you'd want to actually set up a real email sender service to do this. But for developer purposes, you can just click the link to make that confirmed. And there, now we have our new user. So if I go to log in, I'll first log in using my password.
Mm-hmm.
There we go. And then if we go to my user account page, you can see there's now a new passkeys section.
All right.
So on here, I can add a new passkey. And what this is going to do, like if you're not familiar with passkeys are basically a public-private key pair where the private key is stored by some authentication app. And in this case, I'm probably just going to use Windows. You could use, a password manager as your passkey.
Yeah, I use Bitwarden. I like it. It's open source,
great,
and you can do that. You have it on your phone, and yeah, it's really cool. Yeah.
You can use like a security key, like a YubiKey if you want to.
Exactly.
There's a bunch of different ways to store these private keys. But the idea is I don't have to know my password now. I just have this private key, which is being managed by an authentication app. Here, what Windows is doing is it wants to verify that I'm actually me. Like this is really this user. So it's asking me to verify myself before it will store that passkey. And then once that's done, I now have a passkey associated with this app that Windows is managing. Now I'll give it a name. I'll just call it my Windows passkey. There we go. And so now if I log out, and then if I say log in with passkey, Windows will pop up a UI saying, well, which passkey do you want to use? And I'll say, well, let's use that one. And then it's going to verify. It wants to know it's me again. Like Windows doesn't want to just let anyone use my passkey. So I will type in my PIN to do that. Or you could use Windows Hello. And now I'm
exactly. Yeah. That's the famous, based on one thing that you know, one thing that you have. And basically you have your looks always with you. You have your fingerprints. You have all that, right?
Yeah, that's right. Okay, so that's new passkey support. It's built into the Blazor Identity UI for ASP.NET Core Identity. If you just create a new app, you get passkeys for free, and we're adding scaffolding support also, so that if you want to scaffold in passkey support, you can do that. Okay, so the next thing I want to show is some of the observability features, like the new metrics and traces that we've added in .NET 10 to make it easier for you to monitor and troubleshoot your app. I find the easiest way to do that is actually using .NET Aspire. For folks that aren't familiar with .NET Aspire is an application stack that makes it easier for you to build cloud-native distributed applications. Like it gives you integration packages and tools so that you can build distributed apps that are ready to go to the cloud. And it works great with really any ASP.NET Core app, including Blazor applications.
Including Blazor, yeah. And Maddie is really happy that we are talking about Aspire.
I'm sure she is, yeah. Maddie's the PM for Aspire. So I'm the way I'm gonna add Aspire to my Blazor app is I'm just gonna right click and say add .NET Aspire orchestrator support in Visual Studio. Go ahead and do that. And this is gonna add a couple of projects to my solution. I'll tell you what those are in just a second. There they are. So now we have my Blazor app, and then we have this app host project and the service defaults project. So the app host project is the project that like orchestrates my entire application. Like here, I only have a Blazor app, but let's say I had a web API and like a Redis cache, and I'm using Azure services. This is where in the app host project, I would model all the different parts of my app. Like here, I just have a Blazor app, but you could imagine there's also like a web API project here or multiple services, gRPC services. I would model all of that in the app host project so it can handle orchestrating all those pieces. I can run the entire app by just hitting F5, and the app host project will start each of those pieces for me, including like containers and other parts of the app that need to be started, and allow them to all.
That's why I love Visual Studio. I mean, the integration is really amazing, right?
Yeah. So that's what that's doing. And then in the service defaults project, you have just some sample code. Here they're setting up some really good opinionated cloud native defaults. Like if we just look at what this code is doing, it's not rocket science. It's just setting up like open telemetry so we can get all the telemetry from our app. It's setting up health checks so we can monitor that, you know, processes are healthy. Setting up the service discovery. It's setting up resiliency for when you're making HTTP requests, so you have retry logic. Basic stuff that's just part of ASP.NET Core, but the service defaults library just sort of wires all that up for you, so you don't have to. It makes it easier to add to any of the projects that make up your distributed app. Now, I want to show some of the new metrics and tracing that were just added in .NET 10. So this code actually, it adds open telemetry, but it doesn't add all of the meters and trace sources that I actually want to use. This is being updated actually just right now. But I'm going to just replace this add open telemetry code with a few extra lines of code, which are adding all the new meters that we added in 10 and the new trace sources that we've added in 10. So new meters for Blazor, new meters for authorization, for authentication, for identity, for the memory pool that Kestrel uses, and then new trace sources for Blazor, including for like how Blazor manages circuits on the server for interactive server-side rendering. Okay, so that's all I was doing there. That won't be necessary by the time we ship, but for now I just have to do that manually. So I'm going to run this app again, and this time I'm running the app host project. And what's really cool with Aspire is that when you launch an Aspire app, it will actually launch a developer dashboard, which lets you see everything that's going on in your application. So give it a second, and that should pop up. All right, so there, our app is started. And over here, I think it just popped up over my other screen. And here is the Aspire dashboard.
Yeah.
And I love this. This thing's actually built with Blazor. So this is an example of us using Blazor in the product. So that's nice.
Dog fooding, right?
Dog fooding, yeah. Here this is listing all the resources that are part of my app. I just have one. I just have my Blazor app. But if I had APIs or other services, they would show up here. I can click on the URLs to actually see the app. There's the app running. And what I'm going to do is I'm going to do a couple things in the app just to generate some data. So let's go ahead and log back in one more time with our passkey. Let's click on go to the counter page and click on the counter page a few times so that we've got some circuits happening. Go to the home page. Okay, so we've generated some data. So back in the developer dashboard, let's go look at some of the metrics. So here up at the top, we can see that these are the new authentication metrics. Like we can see how many logins we've had in the app. And this includes things like when it's doing two-factor based authentication, like using passkeys. If I just want to see like app logins, I can filter to various specific events that the metrics are measuring, like just the application logins. So there's authentication. We've got a bunch of events, metrics for Blazor itself. Like here, this navigate metric is counting how many times we navigate to each page in the app. So I can see, for example, like how many times have I gone to the counter page, and there I can see I've gone once. The home page.
Yeah, and I love that because, I mean, we used to do observability, for example, in Application Insights, right? But Application Insights is fantastic for the server. You can integrate client events and everything, but it's just more complex, right? And here you have this just out of the box part of the framework.
Yep, and Application Insights, I think, will act as like a open telemetry, like I forget what they call it.
Like a recipient, like a client, or whatever.
Yeah. You can feed your data into App Insights, and that's still a great service to use. But at least in the runtime now, there are just low-level metrics for counting things like navigations that you can just take advantage of. It's sort of a cheap telemetry system right out of the box. Similarly for like any events that are happening in your app, like if you want to see all the on-click events that have occurred in your Blazor app, you can filter on that. Like if I go and let's go click on the counter a bunch more times, you can see events start streaming in. So that's navigations, UI events. There's some lower level Blazor metrics here for like how long your components are taking to render, how long it's taking to update like their parameters if you're like trying to dig into some performance problems. And then what's really great is I love this one. This is the visibility to like how many circuits you actually have in your app. I've said circuits a couple of times. If you don't know what a circuit is like the server state that's associated with each user in a Blazor server-based application. And so it's useful to know like how many users are actually connected to my app and have an active circuit. And you can see that right here. You can also see how many of those circuits are actually in a connected state where they actually have a live connection with the browser. Like maybe some of your users got disconnected, like they swiped away from the app in the browser and the browser killed the connection, or maybe they just went into a tunnel and they don't have network anymore. And so you have a circuit sitting there on the server now waiting to see if the user is going to reconnect. So you have visibility into all of those things right here in the
That's great.
with the metrics.
It's great because I mean, I always say our life would be much easier if we didn't have users, but we also don't make as much money without users. So you want them, right? But you also want to observe what they are doing, right?
Yeah, and you want to observe like how is your server scaling, like how much load is it under, all these types of things.
Exactly.
All right, last thing for observability I wanted to show is the new tracing for Blazor. So in the past, if you were looking at traces for like a Blazor server app, it wasn't super great. You basically saw this one big long connection, and everything was parented underneath that. It was child activities underneath that. It was super hard to look at and reason about in most telemetry or diagnostic tools. It's much cleaner now. So if I actually, let me filter to just the Blazor related traces. So I'm going to go source equals asymmetric core component. So let's just look at the new Blazor related traces. And here we see a very clear picture of what's happening in our app. Like for all the navigations, I can see like, you know, we navigated to the home page and then we navigated to the counter page. And here's all the times that I decided to click the counter button while I was there. We get a nice view of all the actions that are actually being taken in your app through the tracing view. And if you click on any of these,
which is super useful because I mean, debugging is one thing, but at some point you deploy and then you still want to be able to see what's happening. And traces are kind of the next step into the debugging process, right? And deployment process, right? Yeah.
And if you want to like scope down to see like, well, I want to look at just this one circuit, just this one user. If we look at one of these traces, you can see that they're all linked back to a common created new circuit trace event, so you can link them all together. Like if I wanted to go back here and say, well, let's just look at, let me add another filter. Let's look at just the circuit ID, and let's look just at the one particular circuit. I can pick a particular circuit, apply that, and now I'm just looking at that one user to see what's happening in their app, help troubleshoot their issues, understand what's going on, and so forth. So that's the new observability and diagnostics work that we've done in .NET 10 for Blazor, new metrics, new traces. Blazor WebAssembly has a bunch of stuff that's new too that I probably don't have time to show, but like you can export like CPU profile samples, like do perf profiling and get memory dumps from your Blazor WebAssembly apps. A whole new diagnostic story for Blazor WebAssembly apps as well. All right. One more thing. Last thing I want to show is about like what are some of the pain points that we've addressed with Blazor and .NET 10. And for that, I really want to show the new Blazor state persistence work that we've done. So with Blazor components, you now have a declarative way to say that your component has state that should be persistable. Should be if you ever need to persist the state of this component, this is the state that I want to persist. Now, why would you want to do that? Well, there's a couple of scenarios. One is pre-rendering. Like in Blazor, if you have an interactive component, we actually will pre-render it first from the server, like statically, like just generate some HTML from the component, and then we'll render it interactively if it's on WebAssembly, it'll render interactively on the client, or if it's interactive server-side rendering, it'll render again from the server. And if you have any state that you're using to sort of initialize that component, and you don't do anything, then you'll probably be fetching that state twice. Like think of the weather component here. Like this weather component is fetching a bunch of weather data. If this was an interactive component, it would first fetch the weather data to pre-render the page, and then it will fetch the weather again in order to render the page interactively. Ideally, you want to reuse that state, and state persistence allows you to do that. We had a way to do that in starting like .NET 8, but it involves like using the persistent component state service, and you had to subscribe to an event and do all these things. Now it's really simple. All you have to do is like if you have a component that you want to persist some state for, like let's go to the counter and say we want to persist some state here. Let's say we want to just persist the count. You just say persistent state attribute on the state that you want to persist. And then I'm going to turn this into a property. So public int current count. And get set. There we go. Okay. And I got to make my casing match so that this actually compiles. And now I've got some state in this component that will actually be persisted. I don't have to mess around with the persistent component state service. This will just get will get automatically saved when it needs to be saved and loaded when it needs to be loaded. So that will help with pre-rendering. Cool. The other thing this helps with is for like reliability and scalability. Like if you have circuits that have state and you want to free up those server resources, the Blazor will now knows how to now take the state from that circuit, save it, like pause the circuit so that it can later be resumed. So maybe this would happen if like if the client gets disconnected. Like remember we talked about like they swipe away from the app, they're not even using it, the connection gets dropped, and you have a disconnected circuit. Blazor will now automatically just persist that circuit state and free up the circuit, like just release those resources on the server, so you don't have to now be consuming those resources. You can also do things like have a policy where you say, well, it doesn't look like the user's using, they might be still connected, but it doesn't look like they're using the app. Like maybe they had the app open, but then they went to lunch, and so now you just have an idle circuit. You could decide, well, if the circuit looks idle, I'm going to persist it. So let me show you what I mean as my final little bit of this demo.
Okay.
Is like, let me add a little bit of code to this to my app. I'm going to go into app.razor and just add a little bit of JavaScript using a new Blazor API. And so here you can see I'm listening to the visibility changed event in the browser. And if the browser gets hidden, like if the browser isn't even visible to the user, then let's go ahead and pause the circuit, which will cause it to persist. And then later, when the user comes back, so that they're actually looking at the tab again, we can resume that circuit. Okay.
Right.
So let's go ahead and run this and see what that looks like. All right, great. So I'll get the app back up. All right, so here we go. So let me bring up the application, and let's put this side by side with the Aspire dashboard. And then let's go ahead and create a couple of circuits, and I'll just duplicate the tab. So we've got a couple of these. So there we got 2 circuits, and they each have their own count, like 4 and 3. You see that? And now if I go back to the metric that we saw earlier, remember we were looking at the number of active circuits in our application?
I do.
And right now you can see it says I have 2. I have 2 active circuits, and that's true. I've got 2 users that are using the app. Now watch what happens if I make one of these browsers no longer visible. That should now trigger the browser visibility event to say, hey, this app is no longer being used. And if everything goes smoothly, there it goes. You can see the drop.
Yes.
Very slow.
Okay.
But yeah, so like now I only have one circuit being consuming resources on the server. And if I were like to hide this other browser, then I will drop down to 0. So that's how you can make your app more
well, I mean, great way to save resources on your server as well, right? Which is really awesome, right?
Cool. Yeah. All right. So that's
so we're
some highlights of the new things.
Yeah, this is amazing. Yeah.
Lots more, tons more stuff that you should definitely check out. Like we'll have a bunch of I know other people are showing new stuff today. So be sure to check out the other sessions. And if you want to try these features,
actually, that's my next question. So you have resources here. So where do developers go if they want to learn more?
You want to go get .NET 10 by installing .NET 10 from the .NET website. So get.NET 10 slash get.NET/10 will get you the release. If you have Visual Studio 2026 Insiders, then you already got the bits. It's already included with Visual Studio Insiders Edition. If you want to learn about all the new features, check out the What's New docs and on Microsoft Learn. You can always look at our roadmap on GitHub to find out what we're working on next. And if you're interested more in Aspire or doing AI with Blazor and .NET, there's great resources on the .NET website for those too.
Yeah, fantastic. So we also have 2 big events coming up, right? .NET Conf, beginning of November. We have also Microsoft Ignite, which is going to be mid-November, around November 17, 18. Everything will be streamed live. .NET Conf is fully live. Microsoft Ignite, which is also in person. We have a slide for .NET Conf here, so this is great. Thank you so much, Dan, for your time and for sharing your knowledge with you. Any final thought in just like 30 seconds?
Just thank you for everyone in the community that's helped make .NET 10 so awesome. All the people that submitted bugs and gave us feedback and contributed code. Really appreciate how the community has supported us. We hope you enjoy this release as much as we've enjoyed working on it.
Fantastic. Thank you so much, Dan, for your time. I hope you have a great day. You're just starting your day in Seattle there. Continue to build amazing things, and we'll see you next time. Thank you so much.
Thank you. Happy Blazor Day, everyone.
All right, so we are continuing to be live with you all, and now we are going to welcome Ed Charbeneau. Ed, welcome to the show. Thank you so much for joining. So Ed, you are actually a Microsoft MVP. You are an international speaker. People know you through the Blazor community and everything. This is amazing. You're also a developer advocate for Progress, which is great. I believe you're based in Kentucky, USA. Is that still correct? Here we are. Tim. Oh my God! So okay, my my list
I think I
is not
am
in the
next,
right order.
Laurent.
All right, Team Purdum. I'm so sorry about that. Team,
That's
welcome
okay.
to the show. This is live, people and ladies and gentlemen, as you can see. So,
No
Team,
problem.
you are Director of Product Development at Dymaptic, and you are known for the GeoBlazor mapping library, which is really cool. And I use Blazor a lot for mapping-based components, etc. So we are going to be looking forward to check this mapping library. You are based in Iowa, so still in US, very international day today. You're a frequent speaker at conferences. And today you are going to talk to us about Blazor render mode. So I actually just mentioned that in the introduction with Dan Ross, where you have those different render mode. So first of all, team, welcome to the show. How are you doing today?
I'm good, thank you. Yeah,
fantastic.
I'm excited to be here.
Yeah, that's great. So actually, why don't you just take it on and show us what you have to show?
Okay, great. Yeah, if we want to go ahead and share my screen. So yeah, as Lawrence said, I'm going to be talking about the Blazor render modes, and he did a good job introducing me, so I don't need to tell you much about myself. The Blazor render modes, they start with a static server mode. Actually, originally, Blazor didn't have a static mode, but starting in .NET 8, it does have a static mode. And then you have the interactive server mode, and we'll talk about what each one of these is as we go through this. Interactive WebAssembly mode, interactive auto mode, and then just to give a complete picture, I'm also going to talk just briefly about Blazor Hybrid, which is not technically a render mode, but it kind of gives you a complete picture of how you can use Blazor in different scenarios. So starting with Blazor static server render mode, you start on the server and you get a request in, and it starts rendering the pages which render the components, and then that's all sent down to the browser as static HTML. And that might have, JavaScript and CSS files with it as well, but it is all static. If you want to do anything after that comes down, you can post back with a form, or you can navigate, to a different page. But it is all, typical web requests and full page load type requests going back to the server. So this is very similar to what you would see in the older frameworks for ASP, Classic, ASP.NET, ASP.NET Core, Web Forms, MVC, Razor Pages, all of those. And like I said, you only get static HTML, CSS, and JavaScript, and it only supports that single render with form postbacks, and you don't get any interactive updates via C#, but you can still use JavaScript. So if you did start using Blazor in .NET 5, 6, 7, you would be familiar with things like the on-after render method, and that actually is then missing or is not called from a component that is in static server mode, because nothing happens after the render. It is static, so you can't use that method. So it's something to be aware of, that if you write code in on after render, it will compile, but it won't run that code. So something to be aware of. Same with the event handlers in C#. So if you have that click counter that Dan showed with the @ symbol that makes it a C# handler rather than a JavaScript handler, that's not going to fire on a static page. So this is good for things like blog posts, help pages, the navigation menu, anything that doesn't really need a lot of interactions. So now when you go to the interactive server, the main difference is, instead of just sending down the static HTML, and Dan already mentioned this, we set up a two-way communication with SignalR, which is a WebSocket communication technology made by Microsoft. And that gives us a continuous interaction both directions, so that we can send signals from the server to the browser and from the browser back to the server. Lets us bind the data back and forth. lets us interrupt with the JavaScript and do real-time updates. It also means you can directly access things like your data stores. So you could actually take like your entity framework database context and inject it directly into your interactive server Razor component. That may not be a good idea, but it is possible to do in this mode. And so this gives you a fast first load because it's really quick to set that up, but it is potentially introducing some network lag because on every interaction, it does have to do that round trip to the server and back. With WebAssembly, instead of setting up that WebSocket, now you're going to download the entire .NET runtime. I mean, it's a version of the .NET runtime that's specifically created for WebAssembly, and it is they made it as small as possible, as fast as possible, and they're still working on that all the time to make it as performant as possible. But it is completely downloaded as WebAssembly and run on the client. So then the client in the browser starts doing that rendering of pages and components and starts all the interaction there on in the browser. So then when you want to actually communicate with your database, say, and get some data, you actually have to now set up your own communication back to your server, just as you would with like a desktop application or a JavaScript SPA application. So you would use HTTP client, or you could set up your own SignalR connection back, or use gRPC or any other web communication technology. But you do have to set that up yourself now. So this does, like I said, run in the browser. You can still do live data binding because it's all happening right there, real time, JavaScript interop. But you do have to set up your own calls back to the server. One thing to be aware of that some people aren't aware of if you haven't done this before is that WebAssembly, like JavaScript, is by default single-threaded. And so if you're used to having lots of threads on a server, you can still do like asynchronous programming, async await still work. But if you do some really like heavy data intensive operations, it is possible to freeze up your UI on that single thread. So it's something to be aware of. And I know I've talked to Dan before, and they're always working on ways to improve this and offload things to web workers. And there will be more coming out with that in the future, I'm sure. Of course, since we have to download that .NET runtime, that does mean the interactive WebAssembly is slightly slower the first time you visit that page because it does have to download that. But once you download that after the first load, you don't have that back and forth on every key press, on every click event. So it's much faster. You don't see that network latency, that lag on every event. And this, I would say, is the closest to JavaScript SPA framework. So if you're familiar with Angular or React programming models, this is closest to that because it is all running in the browser. One other thing I'll mention is I think the apps that Dan was showing were Blazor web apps, which is kind of the standard now since .NET 8 of how to create a Blazor project. In addition to Blazor web apps, you can also do WebAssembly as just a standalone project where it's just WebAssembly, and then you might host that instead of in an ASP.NET Core app, you could host it in like a static hosting provider. I think Azure has something like that where you can just host static files and then they'll just download to someone's browser and then run the WebAssembly there. In the auto mode, you start with the server creating the SignalR connection. And then while that's running, while you're visiting the site, it's also downloading the .NET runtime so that when you refresh the page or come back to it, it then switches over and starts running in WebAssembly. So this is kind of the best of both worlds because the first time you visit, you get that quick connection with the WebSocket. but then after that, you get the quicker responses that you get from having it close with the WebAssembly. The one thing to be aware of, though, is, like I mentioned, the setting up your own connections to the data from WebAssembly, or being able to directly connect to the data in server mode. You now have to think about, how am I going to abstract those connections and those communication pieces so that this component can run in both places. It can run locally or in the browser. All right, and finally, like I said, I just want to mention Blazor Hybrid real quickly. This is running Blazor in a web view, and this typically you'll hear it used a lot in .NET MAUI, but it also works in WPF and Windows Forms. And this is running natively with .NET code, so it's running the same code as the rest of .NET MAUI or WPF. So it's not running WebAssembly, even though it seems like it's running right there with the browser. It's not actually running in the browser like the WebAssembly is. And it has access to everything that the device has access to. So if you're familiar with MAUI development at all, there's the Bluetooth APIs and the camera APIs, and all of that you have access to right there in Blazor Hybrid. The nice thing about this being available is that you can now reuse the same components from your website to your desktop to your mobile applications. And you can set up a shared library where you're just sharing that code in all of those locations. It's really kind of the write once, run everywhere solution. And like the interactive modes, this always does fire that on after render. So it's always interactive. And we'll talk about how we define the render modes in a minute, but you don't have to put this render mode tag on Blazor Hybrid because it's always interactive. All right, I'm going to switch over and show an app here that I wrote. So this is a Blazor application. And this page, you can see it says right here, current render mode is static. And you can see it does there's some things that bounce around and stuff, but those are just CSS. So that there's actually nothing interacting with the server or no code running on this page. But if I go to interactive server, you can see it switches and says current mode server. And now it has set up that WebSocket connection. And so when I'm dragging around this map and clicking on things, there is some data going back and forth between the server and the browser. And then on the WebAssembly page, it's now downloading everything to the browser and running everything on this page locally. So when I click on the map, and actually these maps do run through a JavaScript layer. And so GeoBlazor is a wrapper around the ArcGIS JavaScript SDK. So we have C# code that's then calling JavaScript code, that's then calling servers that have all the map tiles on them and bringing it all back to C#. But that's all happening in the browser on this page. And then you can see it's updating the C# here for putting in the click points where I click. It happened real fast, so you may not have seen it there, but if I refresh the page, watch real closely at the top, and you'll see that it will say static for just a minute as it's downloading that .NET runtime. Okay, so you saw that it took a minute for it to download the runtime, and then you have that going. Now, if I go to Interactive Auto, now that I've already downloaded the runtime, it's probably going to go straight to WebAssembly. So we'll see. Yeah, it did. So since the WebAssembly has already been downloaded for this site, and of course all the pages on the same site are going to share the same data cache, then it doesn't have to download it again. It just keeps it, shared. If I was here on the server page and I did a hard refresh, and then I came over to the auto page, then you can see, okay, it started with server mode, But then if I just refresh again, now it's going to switch to WebAssembly because now it's re-downloaded that runtime. So you can see that it does switch back and forth depending on whether it's ready with the WebAssembly or not. One other thing I'll show you, if you open up your .NET tools, if you're in debug mode, you will see this .NET loaded. That is the WebAssembly runtime downloading. So when you see that, you know your WebAssembly runtime is downloading. And if you see WebSocket connected, that is the SignalR connection. So that is your interactive server. So when I see WebSocket connected, and of course the .NET runtime is only going to download once, no matter how many pages I connect to. It doesn't need to re-download it unless I do a hard refresh. But notice the WebSocket disconnected when I went to a WebAssembly page. And then if I go back to a server page, it reconnects again. So like Dan mentioned, it doesn't just hang out there. If it's not needed, it's going to disconnect and save some resources. Okay, so we'll see if anyone finds this funny, but I tried to come up with a joke about these render modes. So static server orders a fancy drink, but once it arrives, they never touch it. Interactive server walks in, sets their cell phone on the bar, leaves, and then begins ordering drinks over the phone. Interactive WebAssembly brings their laptop with them and boots it up before ordering. And hybrid always comes dressed up to look like a local, no matter where the bar is. Just another way of thinking about the different render modes. So what does this all look like in your code? Dan showed a lot of this during his presentation, but here is an ASP.NET Core Server project with Razor pages and Razor components. The Razor component is the building block of Blazor, and that means a .razor file. As he mentioned, Razor syntax was used in MVC and Razor pages, but those have a .cshtml file extension, and so that's how you can tell the difference. If you see .razor, that's called a Razor component, and that's actually the building block of Blazor. So it's a little confusing, but if you see .razor, then you know you're looking at Blazor code. And the difference between pages and components is mostly whether it has the page routing thing at the top of it. So that's the server project, and it can have both pages and components. The app is kind of the top level thing, and if you opened that up, you would see the HTML head and all of that. Sorry, clicking in the wrong place here. WebAssembly, so this is the client project. When you set up, you go into Visual Studio and you set this up, you do have to choose your render modes as you're going through the create new project. And if you don't choose interactive WebAssembly or interactive auto, you won't actually get this project at all. So if you think you will use that at all, make sure you choose one of those render modes, because otherwise you won't get this project. You'll have to add it yourself later, which is possible, but just so you know, it won't be there. The project reference is from the server. The server references the WebAssembly or the client project. That means that it can see all the files in that project. So not only can the server run all of these files, but it can also run the counter file. So I could put interactive auto on the counter, or I could even put interactive server on the counter, and it would still work because the server project can see it. Also, like we mentioned, when the server serves WebAssembly, it's taking that whole client project and serving it down with the .NET runtime, and that's what's actually running. So you can also, like I said, with sharing code with Blazor Hybrid, you could have a Razor class library, or just for sake of organization, you might want to put all of your components in a library like this. And in that case, usually I put the project reference here, pointing from the client project to the Razor class library, because then, of course, the references flow up to the server, and the server can see all of that, and the client can see what's in the Razor class library as well. So again, if anything is in the server now, the client can't see it. So it cannot run any of that code, but it can run anything that's in these two projects. So if you want a component to run in interactive WebAssembly or in interactive auto, which also includes WebAssembly, then it needs to be in one of these two locations. But if it's going to run statically or run with interactive server, it can just be in the server project. And just real quickly, here's what it looks like to set it up. And if you do the new template, you can see all this, so you don't really have to figure it out yourself. But if you do mess it up, this is what you're looking for. And if you only want one or the other, you may just take out some of these lines. Pretty easy to read. And then when you're choosing how to define which components are in different modes, you can either define it at the top of the component file, or you can define it when you're creating a component or when you're declaring a component like this. You could also define it for the entire site, and I think that's even an option in the templates as well. So that would mean that everything is in that mode for the entire site if you put it on the routes. If you don't define a render mode at all, and there's nothing on the parent component, then that's going to be static by default. And so the top level now, since .NET 8 is static, once you define an interactive mode, all the children of that are going to inherit that mode. So you can't mix and match. Like you can't say, well, I want this to be interactive on the server, but then inside that I want an interactive WebAssembly component. That doesn't really work. You have to kind of pick your interactive mode, and then that part of the tree inherits that mode. And then in my sample app that I was showing you, the way I was getting that current render mode to display there was with this little piece of code here, renderinfo.name, which I think they just added in .NET 9. So that's pretty new. All right. I'm looking at the time. We don't have a lot of time to talk about this, but just real quickly, this is what it kind of looks like to the life cycle of a static page. So you have your first render, which does onInitialized and then calls onParameter set. Subsequent renders go right to onParameter set, and then the render, and then the DOM updates. And like I said before, you need a perform post or navigate to go back. And then in interactive modes, it follows that same pattern, but then you get on after render async. So now you can do things, okay, if you want to interact with JavaScript, you need to wait for that because the JavaScript connection isn't ready until after the render. So the JS runtime that you talk to, you need to communicate within that method. And also the click events and other event handlers, DOM events, you can hook up those handlers in your own methods. And when you react to something and you change like a bound variable somewhere in your Razor markup, that's going to cause a re-render, which is going to then re-render the whole thing. You do want to be careful that you don't cause a loop by like changing a variable in your on after render that would cause another render and make the whole thing kind of loop around. There's a couple of other topics that go along with render modes, like pre-rendering, which Dan already mentioned. It's like it renders it once on the server first. And something he did mention that it causes your data to load twice. Also, don't do anything that isn't safe to repeat in that onInitialized method, because like if you had your counter counting in onInitialized, it's going to count twice because of the pre-render step through. And then streaming rendering is you can use that with static mode or with pre-rendering, and it is a way to like show part of a large data set loading at once. That's pretty much it for me. There are a bunch of different resources that we can share here, and I'm just going to show the main one, which is my website, timpurdum.dev, because I have links to all the other ones. So just to save time, I can just point people there and they can find whatever they want from there.
Fantastic. Well, this is cool. We were just commenting off screen that this is one of the more technical aspects of using Blazor, right? But it's important to understand those aspects because it's going to impact performance, it's going to impact a whole lot of things, right? So this is really cool, clear explanation. So I appreciate that. We actually have a question from the chat, and so I hope you can answer it. Personally, I don't know the answer. So HA, the user HA is asking, how do these modes impact the use of the identity framework? And for example, he's doing some identity API calls to a separate project for security, and he was wondering if there are some things that you need to consider in terms of using the identity framework.
Yeah, I bet Dane could answer that better than I could, but I do know what I usually do. I'll tell you what I do for this is I will usually take the latest version of the templates, and I will choose to create a template with all the authentication, like the individual user authentication, and with interactive WebAssembly or interactive auto mode. And it will come with all of that kind of built in, and you'll see in there a way that it kind of persists. There's like persistent authentication components that basically take the authentication from the server and bring it down to the client project. And kind of, so all the authentication is happening securely on the server, but then it is persisted into the client from the server, and so then it does work in both places.
Okay, and that's really cool, and it works in different modes as well, right? Yeah. All right. Well, that's fantastic. That was great. Thank you so much, team, for coming here. Sorry for the small confusion in the beginning. But yeah, I'm really happy that we were able to have you here. What time is it in Iowa right now?
It's about 11 o'clock in the morning.
11 o'clock. So this is cool. We are at 6 p.m. here. It's a very international day today, and our next speaker is going to be based in Seattle, James Montemagno. We don't need to introduce here anymore. Nonetheless, team, thank you so much for joining us on BlazorDay today, and I hope we'll see you next time.
Great. Yeah, thank you for inviting me.
All right.
Bye.
All right, so for our next session, I'm going to introduce someone who doesn't need any introduction. I believe it's James Montemagno. Hey, James, my friend, how are you doing today?
I'm doing good. You can still introduce me. It's fine.
Okay, so I will do that. So you are a principal lead program manager for the developer community at Microsoft, and that sounds, very exciting. And you work with people like Scott Henselman and other people in the team, right, to increase basically the reach of the developer community, and we collaborate quite often as well in the developer relation mode. So this is really cool. You're going to talk to us about building a production level Blazor web app with GitHub Copilot. And now we are starting to touch into AI and how AI can help you to build, right?
Yeah, I think going from that super technical part to all vibes, Laurent, all vibes.
All vibes, yeah, that's really cool because people need to get started somewhere. And so basically our executive managers can start coding, right? And then after that, we'll just go and fix the bugs. That's really cool.
Or you can just, start coding all the time. I think that's the magical part that I kind of talk about is is, you know, as a PM, as people that, you know, even as a developer, you only have so much time to actually code. So some of the tools that we have at our fingertips are there. And what I want to demystify is that it's not just vibes, it's real production things that you can build and you can fix and you can add features to in like no time at all and just have fun. So that's what I'm going to talk about today.
Fantastic. Well, I can't wait to see the session. So please take it on.
All right. Sounds good. Thanks, Laurent. Okay. Let's go ahead and bring up my screen. Perfect. All right. I'm going to have some audio during this. So I'm going to turn that on. But if Laurent, if you talk, then there's going to be an echo. So I'm just going to go for it. I got an action-packed 25 minutes. I'm super excited about it. As Laurent said, I'm James. This entire thing, it's all vibes all the way down, all the way up, all everywhere, vibes all the time. That's all you really need to know about what is happening today. Vibes are everything that I live for. And whether I'm actually coding with vibes or I'm just living and loving it, life with vibes, that's what I'm all about. So everything that you're going to see here was built with vibes and AI along the way. So what did I build? Well, this year I built and shipped more production code than I ever have in my entire life. And actually I've updated, shipped, and managed, like 4 different huge websites. One ginormous. I've built and shipped Blazor hybrid applications to the iOS App Store in record time in like under 24 hours. Built and shipped applications for things that I'm doing here locally, like bingo management, my personal company website. And the main application that I'm going to talk about today is feedback flow. But let's talk about these applications. These are all 100% with Blazor and in different modes as well. And the first is my scorekeeper. My wife was out with her friends and they're playing board games and she needed an app. So I built it in about an hour and it's live on the internet, myscorekeeper.app. It's a Blazor WebAssembly application. Uses static hosting. Boom. I pulled it down, converted it to a Blazor hybrid application, and now it's on the iOS App Store, which is mind-boggling. I play bingo locally at some of the different places around town, and I was watching people use virtual bingo management software, and it upset me. So I vibed out an entire bingo website, including standard bingo, but also like kind of custom bingo names and things like that as well. Again, Blazor WebAssembly app, shipped and published under 48 hours. And then my personal website, this used to be just a blank page that said, this is my LLC. And then I just asked Copilot to make it modern. And that's what I got as a brand new, beautiful website. Now, the biggest application that I'm going to talk about today is feedback flow and actually how I built it. These are all production applications, but this is a multi-tier, multi-service, rail running application that uses AI, uses functions, uses databases, uses the entire stack across the way. And I'll talk a little bit more about this application and like why I needed it and why I built it and how I built it as well. There's a problem as a PM, as kind of Laurent was saying, is we have a lot of awesome content out there that we publish. The teams are doing amazing work and often we're talking about it everywhere, right? So when we do a post, for example, about, let's say, the Copilot profiler in VS26, we can see that multiple accounts are posting across Blue Sky and X and LinkedIn, and Mads is on Reddit, for example. We have all these comments. So the problem here is that we want to grab all these comments and we want to be able to pull them all down from these multiple sources and also do an analysis on them as well. So that's like the problem that I was looking to solve. But the real problem is that I actually only spend a tiny fraction of time coding. There are many, many things that I'm doing nonstop that is not coding. And the actual amount of time that I have to code is very little. Most of the times I'm joining a Teams call, leaving a Teams call, joining another Teams call. Right after this, I'll join a Teams call with Scott Hanselman and then do that. So the amount of time that I have is very small. And of course, I'm a PM and I'm a developer advocate. But even as my time, if I think back of like the time that I spent as a developer, and when we research how much time developers actually spend writing code, it's actually a small part of the day. At the end of the day, it's like 14% of actually like writing code. So whether you're planning, designing, deploying, these are all important steps. And what I believe and what I've seen and what I know is that really GitHub Copilot can help you with every single aspect of it. So you can write more code, fix more bugs, implement your designs faster, refactor, migrate faster than ever before. Okay, so let's see what I built. Okay, so I'm going to go over to feedbackflow.app. That's a real website on the internet that I host. That's me. So what is this website? Well, I'm logged in here with my Google account, and I also have GitHub admin, GitHub authentication as well. And basically, you just paste in a URL over here and from any of these supported platforms, and it does stuff. So let's take a look at this unboxing Blazor in .NET 10 Preview 2. It's got a whole bunch of comments. I ain't got time for that. Let's go ahead and paste that in there and say analyze comments. So what's going to happen is going to pull down all the comments, going to pull down all the replies to it, and then it's going to do an analysis using GPT-5 Nano, because it's very, very cheap and pretty quick, to do a full analysis of this content. And I could have added multiple URLs there, and you got to have some confetti JS in there so you know it's there. So this here is the entire feedback analysis, gives me a TLDR. If you're a PM, if you're shipping features, you get positive, different analysis. You know, this can help the team in real time get these core themes of maybe what they want to implement into the upcoming versions. So you get these really key insights in here as well. You can go back, you can customize the prompt inside of here. You could add more URLs, and you can see as I hover over everything inside of here with my cursor, it hovers just a little bit. And that's how you know it was built 100% with AI. You can just paste some text in here as well. So we get this back and forth. This is a Blazor server application through and through. If I came over here into my feeds, I could search for like Azure functions, content on YouTube that will pull it down. I can go ahead and like open this directly in feedback flow, open it up. I could look at Hacker News articles. I have configured reports here. So I could look at like the .NET Reddit community, for example, get statistics. I get weekly emails in my inbox using Azure Communication Services, which is pretty cool. And then I can even like look at save. So I can save these get saved into blob storage. And then here's one that I did the other day from Y Combinator on Hacker News. I can view it, I can share it, and I can, you know, give this out to the world basically, which is cool. You got light theme, you got dark theme, you got your themes. On top of that, I have a full admin dashboard. Over here, I have multiple user account levels. So here I can see that I have like how many users I have, the active rate. I can look at user distribution, what accounts they're using, all of this here, all these usage consumptions. I hide a bunch of stuff. I have an API built into this. I have an MCP server built into this, and a lot more. If we take a look at the code over here, I have this up and running. We can take a look at my project structure. I have a app host, so everything is orchestrated with .NET Aspire, of course. I have a core Azure function running in the backend here for all of my Azure functions that are running. I have a shared big library for all my models and analysis and JSON context that's coming back from the services. And then I have my web app. So here are all my components. I can see all my pages. I can see all my admin pages, for example, and my stylized CSS there. And of course, my little Pokemon that are hanging out with me in time here. If I open up this, we can see here's my Aspire dashboard. So everything's running here. I can see there's some error with my function running here, but I can open it up. I have everything running locally on localhost. I get all my logs, I get all my traces, right? This really helped me develop super fast. Additionally, if I go into here, I can say enter API keys, and we're using the extensions to actually like be able to like put all my API keys and debug locally, or just use mocks for everything as well, which is super cool. The fun fact is every single bit of line was 100% generated by Copilot. I did not write a single line of code in this entire application. I refused to, and I didn't. So all of that, including the MCP servers, the API, the backend, the front end, everything about it was 100% written with Copilot and deployed, including the CI/CD pipeline. I didn't write a single line of code. Or did I? Because am I not just Copilot at the end of the day as a friend, as a colleague, as a pair programmer? So yeah, but as far as lines of code written, none by me. So that's the app, Ed, believe it or not. So let's talk about the architecture. I have my Blazor server application on app service. I have an MCP server that can run in Docker locally. I also have an MCP server that can run in Azure Functions remotely. All three of these talk to an Azure function because I love Azure Functions. And then that Azure function talks to table storage, blob storage, APIs like authentication services, talks to AI Foundry for the AI integration and communication service. All that is integrated into .NET Aspire and application insights along the way. So everything. Again, everything was 100% built in VS and VS Code with GitHub Copilot and agent mode. So the question is like, how did I do it? And the real answer is David Fowler built this. No, I'm just kidding. I mean, he kind of built something as a starting point in general. I was talking to David Fowler, and he was like, wow, we really need something to analyze this. And he built a series of command line tools that would go off, and you'd give it an API key, and you'd give it a YouTube API key, and it would go grab comments and put it in a JSON file. So you could bring it into Copilot or ChatGPT or something, or your favorite tool. And I'm not really a command line person. That's not my vibe. So I decided to take what he had, which is just a few console applications, and start to refactor it. So I sat down, and this was in, I don't know, February, April, something like that timeframe, April timeframe. And day one, I just started to get to work. And this is the commits that we see here. I started to pull out all of his code down here at the bottom into a refactored project, refactored the API integration, implemented Hacker News, implemented the GitHub API, added Azure Functions, enhanced Azure Functions, and added a UI with Blazor. Started to improve Markdown files. By day two, I was implementing an MCP server, adding dependency services, enhancing comments, different analysis, getting CSS rules all set up. And legitimately, in under 3 days, I had a full working prototype up and running. This is what it looked like after day 3. So here I had different integrations, some that actually David didn't have. Inside of here, I had beautiful light theme, dark theme. You can see some inspo here from the original that was going on, including that big analysis button. So for originally, you had to select different pieces of content that you wanted to analyze. So I could go into like Y Combinator and just paste this in and analyze this as you saw. And of course, I have not changed my confetti since then. So the confetti continues to go after analyzing the analysis as well. So we can see it go off and we get some there. But I had very limited features and capabilities, just the ability to copy the markdown inside of here. But it was calling real services. Real things were happening after a few days. And I thought I was onto something. I thought this was pretty cool. I reached out to Mark Rusinovich and I was like, hey, Mark, like I took your podcast that you're doing with Scott. And he was like, that's cool. And I was like, wow, mission accomplished, time to retire. Mark Rusinovich telling me something I built was cool. And he's like, is this vibe coded or augmented? And I respond, vibes all the way down. Fowler's like, this is good. And then I sent him this email that Mark thought it was cool. And David didn't actually realize how much code I didn't write. And then I told him, I didn't write any of it. The vibes all the way down. So how did I actually build this thing, right? Well, I just really gave in to agent mode, to be honest with you. This was really coming of time when new models were coming out, like Sonnet and new GPT models that were being released. And I wanted to get really good at this amazing tool in my toolbox. And I looked at it as that way, just like IntelliSense and IntelliCode and other refactoring tools that you might use in your editor. So I wanted to get really good. I wanted to master this tool, this amazing piece of functionality that was in there. So that's what I did. I gave all in to agent mode, and I created my base project structures with file new project. And I said, let's do this. Let's go. And I wanted to learn the best practices along the way. Now, when I got started though, it wasn't easy. And it felt a little bit like this.
Just make it more modern. No, not that modern. Maybe a little bit more modern. Think deeper. Try this bottom thing on the bottom that websites have. No thinking aloud. One must not code the code. What am I, a stone man? Vibes only.
That's how I felt. I was like, I have no idea what I'm doing. I'm just going to tell it simple things that I wanted to do over and over again. I just wanted to vibe. And what I realized is that how to get better is all about prompting and context. So really, how do I improve my prompts and what I'm giving the agent? What context can I provide? And how can I draft up an idea? Just like I would do for myself if I'm doing some specifications or I'm writing an issue for myself, create a plan and then have it execute on the plan for me. That is sort of the flow that I needed to start to understand to work better with the agent. Now, as I started to do this, there's tons of ups and downs in this vibe coding.
Senior game engine developer. Write me a new to-do list app, please. Good. Really? You're gonna use Node.js for this? No, not Rust. No buffer overruns. No memory leaks. Maybe it does have a future. What did I learn C for? Don't use PHP. Don't use Perl. Don't use JavaScript. You are a 30-year veteran coder from NASA. Why are you rewriting it to Lisp? Am I allowed to use those images? Who's doing moderation for this site? Is this even GDPR conform? Still not working. You only work on the UI. Rest of the code is holy. You don't touch it. No. Don't come back until you're finished. Great. Why is the bill $400? What is the first line in the requirements document say? Okay, do not, I know you're hallucinating. It's not how lifetimes work. Do not change the color scheme. Oh, no, you don't use clear both on a Flexbox. No, we're not gonna use AWS again. Redis cache.
That's how you feel sometimes. You're like, what is going on? There's ups or downs. It's working. It's not working. Not listening to you. And you just wanted to do it. Just do the thing that I want you to do. And what I found over time is it's really about context. It's about context and instructions. And especially when I'm working in a code base like Blazor and Blazor Server and have special things that I want to work, or special things that I can do to provide that context. And the first thing is the Copilot instructions. These are custom instructions that become your best friend. These are sent with every single request to the agent to help it understand how your project is structured and how you want your code to be written. So here, as I scroll down, we can see things about how to even build and test the application, where the repo is at, what branch I like working off of, how to work with Aspire, how to run it with Aspire, what is my tech stack, right, for example. Now, the models can infer this by looking at your code, but if you give it the context, it doesn't have to. Here for Blazor, I'm giving it how I like my CSS and scope CSS files, how the theme support will work, how I want icons, for example. And as I'm working with it, this gets sent, so I don't have to send it time and time again. Now, you can put it in one big Copilot instructions file, but you can also, for example, use scoping here. So this can apply to specific files for your Razor or Razor CS or Razor CS. So you can break this down into little chunks to really help it out. And there's a great repo, the awesome Copilot repo that has tons of these built in. There's also agents.md that work in VS Code and the GitHub coding agent, which I'll talk about in a bit, which is kind of a complementary to the Copilot instructions. Copilot instructions are for Copilot. Agents instructions are sort of a, cross-compatible version of that as well. So be aware that those also work too if you're working with multiple agents. I also think that one thing that I really worked on is something called chat modes. And chat modes are super powerful in VS Code, where you have things like ask, edit, and agent. But you can also, put chat modes into a planner mode, a designer mode, or in this case, this is one that I pulled from Awesome Copilot, which was all about kind of an expert .NET software engineer, that you give it this mindset of how you want to code. And this isn't attached to the prompt. It is sort of the system prompt that gets sent along with it. So it kind of will guide you in a mode. So if you're working on an API, you might have an API mode, for example, or a front end mode, and how you want the agent to work. I also think prompts are sort of your best friend as well. Prompts are reusable files. This is one that I have in my project here that I created, which is all about creating a Blazor component and how I want to. Now, I didn't actually write any of this code. I had Copilot generate the prompt for me based on the code that I have. Of course, I don't want to waste my keystrokes. But these prompts enable you to have reusable system prompts. So here I would define, I'm going to create this new login component, and I would use this prompt that would guide it to how I want it implemented over and over and over again, which is super duper nice when you're working in a team and you're scaffolding out a lot of code. So kind of be aware of exactly these tools in your toolbox. So here you can tell it how you want it to, do you have namespaces and parameters and dependency injection, state and lifecycle, and even error handling to follow these patterns as it's going. Also, MCPs are your best friend. Model context protocols enable you to connect your agents to additional services to get context from them. Just yesterday, I went off and I was using the Microsoft Learn MCP server here and connecting it up. And I was like, hey, how do I optimize this Blazor app for the assets for .NET 9? Because I know I'm definitely not taking advantage of all the awesome stuff. So it went off, it searched Microsoft Docs for this, brought it back. And then I said, hey, based on my web app, come up with a plan. And then I asked it to create a bunch of GitHub issues for me so I could go and implement them as well. And when you do this, it starts to feel a little bit more magical.
Now, given all the wisdom I gave you, my 2 books on software architecture, my 3 talks on why you shouldn't use solid principles, and my 6,300 cursor rules file. I believe in you.
And you really start to believe in it as you start to give it this context. The more you get in the flow of having this navigation through custom instructions, through these prompts, through your best practices that you instill and you ground the model in, the better the flow, those vibes that you get in. This is really important. I'd say actually now I don't have to run my application locally at all. Actually, I don't. I would say for the last several months, I just tell it what to do. We do it. We check it in on a branch. We create staging environment and go. I review the code in real time, obviously, as the human in the loop. But as I'm reviewing it, I don't even need to run it local. It's just so good. I'm not going to do the MCP one. But at the end of the day, just remember, context is magic. And the more context you can give it, the more guidance you can give it, the better results you're going to get. If it's not doing something how you like it to be done, correct it, and then tell it to go update the Copilot instructions for you based on this and review those. I'd also say love all the models. There's many models. There's a new model every day. There's a new Codex model, a Suite model, a whole bunch of other things. When I first was getting started, Claude Sonnet 3.5 was out. I used it a lot. I use a lot of 4.1, a lot of 3.7, a lot of 4, a lot of GPT-5 now is my default. But love all of them based on the task that you're doing. Every model is a little bit different, whether it's more pointed and more up to date or more distinct and really focused or more exploratory, like the Claude models that just want to like do everything under the sun. Now, there are so many models, so don't feel like you have to jump on the new model right away.
They changed the model. I just learned 3.7.1. Everything I know is now invalid.
So explore and try different models. Just go into Bing or Google and say GitHub Copilot, LLM models, which to use. And there's great blogs, there's great documentation of how to use and pick different models, their speed, what they're good at, and also read the prompting guidance as well. That will really help along the way. And when a new model comes out, don't feel like you got to jump on it, especially if you're like really good at crafting and with a specific model. I've worked a lot more with GPT-5. I've really enjoyed how I like it. But then sometimes I know based on a task that maybe is a little bit more exploratory through my code base, going to be far reaching. I'll swap over to Claude Sonnet, for example. And you can also have the models check the work of other models as well. Now, the thing that I really want to point out here is coding agents and background tasks. This thing has been a game changer for me. This is even newer than agent mode. But think of it, when I'm in agent mode, I'm doing work on my local machine. I'm working with the agent locally inside of VS Code. I could have multiple threads up. And it's all working in the code base locally. Background tasks and coding agents are doing work on other machines in the background that you're handing off tasks to asynchronously. Just like you would give it, pick up different tickets, right, for different team members. The coding agents can be assigned different tasks in real time. The coding agent is magical. In fact, if you looked at the feedback flow repository, you'd see that almost every single PR that's out there that's closed recently has all been assigned to Copilot. I've almost inherently switched a lot of what I do to being design first, opening an issue, or delegating tasks off to the coding agent. That allows you to get a whole lot more done in a record time. Also, realize that prompting bigger issues and giving it more context in the things that you're doing with the coding agent can also be really useful. That admin dashboard I drafted with Copilot, what I want in my admin dashboard based on what's in my application. And then it went off and it just took it over and implemented what you saw earlier. You can also iterate, right? So just because the coding agent starts, you can pick it up, open it locally on that branch, and then go to town. And it's okay to work with AI. I do all the time. As I'm reviewing these PRs in real time, I'm working with it. I'm reviewing the code. I'm understanding what's happening, and I'm testing it in real time. So I am having this conversation back and forth with Copilot and telling it what I need it to do and what I am seeing it to have it enhance it in real time and get it back, including giving it context, like images, for example, that it can read and understand. And then when you're done, you're all good to go. Now, here's a cool case study. When I was first getting started here, after about a month, David brought in Damien and was like, hey, this thing is really cool. I want a shareable URL so I can just share it with the world. And I was like, yeah, I have a save button. I don't know. So literally 20 minutes later, I opened an issue. Fowler, assign it to Copilot. Did and deployed in under 2 hours. And it was kind of revolutionary. I gave it to Fowler or to Damien. And I was like, wow, what a time to be alive. The same thing, I was working with Pierce. This is a feature that rolled out in under an hour and a half. He needed an API that could connect up when he was building different integrations and Teams and Slack. So I built it for him. I specified it, assigned it to Copilot, done in production, done. It was absolutely amazing. I actually did it for this presentation. I added a toggle switch for an individual report when you had multiple URLs instead of combining them all together. Wrote up an issue. It did it. Done. Push it out. Major refactorings, no problem. When I was implementing the Azure App Service Easy Auth into the application, this is a huge commit and huge change. I actually worked with Copilot for over a month on this because this is far reaching in so many aspects as you could possibly imagine. We worked together in a huge conversation of hundreds of comments, hundreds of files commits, and huge amounts of code. And at the end of the day, the code just flows.
Open Vim. My happy place. Can I optimize the loading?
Here are some ways to optimize your Vim.
How could I optimize the loading? I don't know. You're the AI. I was hoping that you would know. I like that. Approve.
So just approve and just go, but always review. Let me wrap it up, Laurent, because I got 2 more slides and then we're good to go. I know it looks like I got a bunch.
And we have a couple of questions.
So here's the last thing in my takeaway. A wise man once told me, how many keystrokes do I have left? And I didn't want to waste any.
I had a friend who said once that he was aware of the number of keystrokes he had left. So you know how old you are, you know how long you can live. You can do the math and find out how many breaths you have left in your chest. How many keystrokes do you have left? I really don't like wasting keystrokes.
I don't like wasting keystrokes either, which is why I use Copilot for not just writing code, commit messages, PR summaries, code reviews, ideation, issue creation, debugging, profiling, and more. Truly nothing is impossible. And that's it. That's all I got. I believe in all of you. And I still have 3 minutes left. Yes.
That's amazing, man. It's the future, right? We are really living in the future. And I use that all the time also, to create apps, even just in the day-to-day when I know what code I kind of want to write, but GitHub Copilot helps me. We have a couple of questions. So the first question, I didn't know that we are saying publicly that GitHub Copilot is actually David Fowler in the background. So is that public now? We can say that.
That's truth. That's just truth.
Truth.
Truth. Yeah.
Okay, this was a secret within Microsoft. So more seriously, though, Marvin Klein Music, one of our viewers, says, how should we know which model we should use? And I think we can maybe say like what is your favorite model and when do you switch model? I like Claude Sonnet for most interactions because it kind of speaks to me in a way that I like. But how do you do that actually? How do you select which model?
That's a great question. One, I never try to use the model on the day of launch because everyone's trying to use the model on the day of launch. I don't know. I would say that, I try to look at the different documentation. Like I said, GitHub has some really good documentation about which different models to use when. I think that with the GPT models, especially the earlier ones, the 4 series, they're a little bit more pointed. They like to be targeted on a specific task and execute upon it. GPT-5 is more of a thinking model, so it is a little bit more thinking. I sort of default to GPT-5 mini because it's 0x premium request, which is great. But GPT-5 can handle a lot more complex work in general. So those are usually my defaults because they're pretty fast, including GPT-5 is faster than some of the other models that are out there. Claude, I like when it's a really complex task and it's far reaching and I need it to explore and I need it to go off and do things that are a little bit more advanced out there. But that being said, always work off a branch. Commits are free and try different models, go back and forth on it. I say I spend about 99% of my time now in GPT-5 though. But don't be scared about trying different models. And then also there's tons of bring your own key models. So you can connect it to local models and other services as well. So not just the ones that are in the box. There's great guidance and documentation from people much smarter than me on when to use what model. But I think you said it, which is like, what do you vibe with, right? You start to actually vibe just like you vibe with. I vibe really close with
there's a
Johan.
part of personal preference to that, right? Which is why trying different models is probably a good idea. Finally, we have a question from a certain Edward Ed Charbeneau, which you might know, who says, "What? No coffee inventory tracker app?" question mark. So
No.
I think that's the next demo, right?
It's probably the next demo, but I think what I really wanted to show off here in general is that I've shown that stuff like 1,000 times. You can build anything really fast, like those smaller apps that I showed, the Scorekeeper app and the other ones. But the difference is that this is really in production. This is on my personal service. People are using it, especially at work. I'm not, tens of hundreds of thousands of people. I'm not marketing it. So I don't want my bill to go up tons, but it's a real service with real authentication, real databases, real things that are out there. So that's why I want to kind of show it off, and that's why I highlight it, and I love it.
Fantastic. All right, James, thank you so much for spending the time with us. Really appreciate that. Have a great day. You are starting your day in Seattle, right? It's still early there, but really fantastic to have you here. So without further ado, we are going to go to our next guest, who is Rocky Lhotka. And I'm so happy to have Rocky here because Rocky, you are not only a friend, but also, I've been admiring your work forever in the .NET space. And Rocky, you are Vice President for Strategy for Xebia. You're also Chief Software Architect at Marimer LLC. And of course, you are also well known for CSLA.NET, which is your, how should I say, it's really what I started to know you for. And I think this is also what a lot of people are knowing you for. You are a Microsoft MVP, regional director, the list, I could go on and on. So Rocky, this is great to have you here. You're going to talk to us about Blazor authentication and authorization. And God knows this is important in those days of increased security. How are you doing, my good friend?
Oh, I'm doing fantastic. It's a pleasure to be here, and I'm really happy to be talking to you.
So happy to hear what you have to tell us. So please take it on, and I can't wait to see your session. Thank you.
All right. Well, I am going to talk primarily about, let's see if I can get my sharing to work here. I would like the entire screen. That would be great. And then I've got a slide. There we go. Blazor authentication and authorization. And so when you're building, like Laurent said, pretty much any app, you have to deal with validation of the user identity. And once you know who the user is, then you have to find out what roles or other information in the user profile, often called claims, and then express those in your application. And in fact, nearly all of the things that I'm working on these days have a Blazor front end. It's just such a fantastic technology. And so I thought I would talk about that today. And so to start with, there are a lot of authentication models that someone might use. And in talking to different audiences at events for the last several years, I frequently ask folks, well, how many people are using some sort of OAuth or something like that, Entra ID or one of the other providers, and it's usually a good amount, maybe half, sometimes a little more than half, sometimes a little less than half, but that is a pretty common deal. And so I will talk about that, of course. There's another large contingent of people, usually it's maybe 20 or 30%, depending on the audience, that use their own internal authentication model. And that might be that they've got all of the user credentials in a database or an LDAP server or who knows what. But the point is they're not using OAuth, and they're not using necessarily anything that's standard. And so that's also pretty common. And then the final thing that I ask, and almost never does anybody say they're using this, but every now and then, is what's called individual accounts, which if you go back into the late 1990s, I think, when ASP Classic first came out, Microsoft introduced this concept of you run a script, it sets up a whole bunch of tables in a SQL Server database, and then they provide for us a bunch of admin tooling and whatnot to maintain users, roles, and all that sort of thing. And that technology has continued to be present and available all the way through the modern today's Blazor templates. And I'm not really going to talk about that very much today at all, but if you use that, you'll be happy to know that it's still there, alive, kicking, and available in Blazor. So before I get into the code, I do want to reinforce the way that Blazor thinks about the user identity. And so at the end of the day, whoever's logged in, so the current user, their identity is maintained in a claims principal. Now, in the past, you might have used generic principal or Windows principal or even iPrincipal implementations. But Blazor requires claims principal. That's pretty much the only thing it uses. And a claims principal's job is to maintain a claims identity. And so the real user identity is this claims identity. And the primary thing about a claims identity is that it maintains a list of claim objects. And so a claim object might be the user's name, there might be a whole bunch of them that maintain the roles for the user. You might have other things like the user's phone number or their department or what region they. Basically, a claim can be anything relevant to a user. And so this is pretty powerful and incredibly flexible. And so that's, I think, a good choice, and I'm pretty happy with how they've done that. So then the question is, inside of a Blazor app, how do you get at that claims principal? How do you get to the user identity? Now, behind the scenes, inside Blazor's infrastructure, there's a whole set of services that do this. And it's important to understand that Blazor is directly built on top of dependency injection. And so there's a thing called Authentication State Provider, which is a service that always exists in a Blazor environment, whether you're Blazor server or Blazor WebAssembly. And the Authentication State Provider is the thing that provides, that's a service, a DI service, and it provides access to the authentication state. And the authentication state provides access to the claims principal, which gets you to the claims identity, which gets you to the list of claims. This might sound like a lot of layers of abstraction, and it is. But it's okay, because most of this is hidden behind a whole bunch of nice abstractions. So usually we don't have to deal with these things, but I always like to know what's going on under the covers so that I can appreciate how it all works. And I'm going through all of this because it doesn't matter which kind of authentication you use. All of these pieces are always in play. And so, for example, if I'm using Entra ID, I'll probably use the NuGet package that Microsoft provides that abstracts all of that. And so I'll never see any of this stuff, which is great. But it is all being done behind the scenes. On the other hand, if I'm trying to use my own internal, whether it be a database or LDAP server or whatever it might be, I might actually have to understand this at some level of depth, because there are cases where I might have to create my own custom authentication state provider. So on the server, and so here I'm going to differentiate between Blazor server and Blazor WebAssembly. Excuse me. Blazor server sits directly on top of, or is in fact part of, ASP.NET Core. And so we have the luxury on the server of being able to just use ASP.NET Core authentication. And I say luxury because doing all of this stuff correctly is not easy. And the reality is that ASP.NET Core sits, or is a successor to ASP.NET, which is a successor to ASP. And my point is that Microsoft has been doing this and maintaining these technologies for a very long time, fixing bugs, addressing vulnerabilities. And so I feel pretty comfortable anytime that I'm using ASP.NET Core Authentication, because I'm like, yeah, this has been tested extensively by who knows how many websites around the world for decades. And so behind the scenes, then what's going to happen is that some code, either code that I write or some other NuGet package, is going to get at the HTTP context and is going to use the age-old sign-in and sign-out APIs to usually create some sort of authentication cookie, although there are many, many other options that I don't have time to go into today. And also the ASP.NET Core middleware on any post to the server from the Blazor client or however that might work will automatically recreate the claims principal. So it'll use, again, by default, normally this cookie to identify that the user is logged in. The information in the cookie is then used in order to recreate the claims principal. So by the time my code is running, and this is regardless of whether it's server-side Blazor code or some API endpoint that's running on my Blazor server, by the time my code is running, I already have access to the user identity because ASP.NET Core did that work for me. So yay, that's a win. On the client, or if you're doing a MAUI hybrid with Blazor, which is a pretty cool technology also, the world is a little bit different. And this is because we're running on a client device. And first off, we have to recognize that all client devices are vulnerable to hacking in a way that servers are not. And that's just because the physical device could be in the physical hands of a bad actor who then could use any number of techniques in order to crack into that device. And as a gamer, somebody who plays online games a fair amount, I see this all the time. Every time there's a new release of a game, especially first-person shooter type games, within hours or days, those games have been hacked and cracked, and people are running cheats, and it's a constant battle on the part of game publishers to fight against that, so the rest of us can have a good time. And but it's just a running battle because they can't truly prevent hacking because all of our client devices are inherently vulnerable. And so this is true for any code that you have that's running WebAssembly or running on a client device using MAUI. Unless you think this is just a Microsoft problem, this is also true for Angular and React and Java and Windows Forms and WPF. And literally any client technology is subject to this challenge, right? But it's something we accept in order to run code on client devices. So, there you go. So basically, on the client device, the Blazor infrastructure is the same in that it has an authentication state provider that provides access to the claims principal. The thing is, on a client device, it's entirely up to you and me to set that claims principal and provide it back to Blazor on demand. And how we validate the user's credentials, that's really up to us. Whether we collect the credentials and then call a web service to validate them, or collect the credentials and use some local device API to verify that those credentials are valid, or however it might be done, that's up to us. And once we've proven to our satisfaction that the user credentials are good, then we can create the claims principal and claims identity, and then we can provide it to Blazor, typically through a custom authentication state provider. So, enough PowerPoints. Let's go take a look at some of how this stuff might work. And so I'm going to start with an app. And of course, like all good, highly experimental people, I'm in fact using the preview of the new Visual Studio. So, wish me luck. Who knows what might happen here. So I have here a typical, fairly straightforward solution that is just a Blazor web application. And I believe this one's created in .NET 8 or 9. And so we've got the web project and then the Razor class library that can contain Razor components that can run either on the server or in the WebAssembly client or both. And so I'm trying in this example to show the whole 9 yards, right? Just all of the options. So let's start on the server, because that's probably the easiest to understand because it sits on top of ASP.NET Core. And we'll start where all things start, in Program CS. And in Program CS, we have to turn on authentication capabilities. And so normally in a Blazor app, you've got these lines here, but we know that we're going to need access to the HTTP context. And so we'll bring in the HTTP context accessor. And then again, just to reinforce, I'll get to the Entra ID in a little bit, but right now I'm focused on what's really going on behind the scenes. This is all of the little pieces parts. It's also the way that you're going to do this if you have your own LDAP server or a security database or whatever. So we'll need access to HTTP context. We'll turn on ASP.NET Authentication and configure it. Now this, what looks like 1 or 2 lines of code, could be massive, right? If you look at ASP.NET Core options on the Microsoft website or books, or do people still read books? Anyway, the point is the options to configure authentication are amazingly complex. This is a simple scenario just saying, hey, I want to use standard authentication cookies, life will be good. Then I'm doing something that is for Blazor, and I'm saying, all right, because I'm going to be logging in the user, I want Blazor to be able to provide that user identity. It'll cascade throughout my entire application. So I'm turning on that feature. And then I also, right here, have, I'll show you the code. This is a mock-up for sure. A user validation service that is going to be used to validate the credentials that I enter. And in fact, this service is the thing that you would write to talk to your own database or to talk to your LDAP server or what have you. If we go down a little bit further, we'll see that after I've set up the app, all the services, then I'm going to tell ASP.NET Core to use authentication and use authorization. This is necessary to turn all of those things on. And so at that point, now I've enabled authentication. So the next piece of the puzzle is that if I go into my components and look at my app.razor, because this is the next thing that Blazor will run, I don't have to change anything here. This is just the standard next step, or in some templates, this would be index.html. So it kind of depends on your project template you used and how long you've been using Blazor, but this is the current. App.razor gives way to routes.razor. And so here I've actually done some changes. So your normal routes.razor does not have cascading authentication state, but I've added that because I want all my components in my entire app to have access to the user identity if the user is logged in. And so I'm literally surrounding, because every page that gets displayed in this block right here, which is wrapped in the router, which is wrapped in cascading authentication state. So therefore, I'm confident that I always have access. So that makes me happy. The other thing that I've done is I've changed, normally this just says route view, but I've changed it to say authorize route view, because once I know who the user is, now I want to enable the ability for a page to say that it is, like, literally the page or component is only available if a user is in a specific role or if a user has a specific claim. And so that this enables that feature, and I'll talk about that as well. So once that's done, the next thing I'll typically do is I'll go into my main layout because I want to show whether the user is logged in or not, and provide some login links or whatever. So kind of the standard is to put it up at the top of the page. And so here I'm going to use this authorize view element that is part of Blazor. And this works because I have turned on that cascading authentication state. So all my components now have access to the current user identity. Authorize view in its default form looks at the current user identity and says, well, is the user currently logged in or not? But that's the only question it's asking right now. And if the user is logged in, so is authorized, then I'm going to say, hello, user, here's a logout link. And if the user is not authorized, which in this case means not logged in, I'm going to show them a login link that they can use to log in. Now, the login and logout pages here, which you can see are referenced here, those happen to be in my pages folder. And so if we look at the login Razor page, so this is just a standard Blazor page, but I do need to pause here and point out that this project is a Blazor web app. So it uses the modern Blazor web app template, and it is using the per page ability to set render modes. And this is important. So the default render mode in this scenario is what's called server static rendering, which means it's not an interactive Blazor page. So there's no SignalR pipeline, there's no WebAssembly. This code literally runs on the server and renders HTML, CSS, and any interactivity occurs through a postback. And for those that have not encountered this, you might be saying, well, doesn't that sound a lot like ASP MVC or ASP Razor pages? And architecturally, the answer is yes, they're identical. It's the same thing. I just get to use Blazor syntax to create all of my server-side capabilities. And so this page is not interactive. That's the key. If it were interactive, you would see render mode, interactive server or something like that. And then this would not work. I want to be clear. And the reason being that later on in this page, I'm going to be using HTTP context. And you should avoid using HTTP context in Blazor interactive pages. If it works at all, it tends to work unreliably. So you just don't do it. All right, so this page, I'm not going to walk through too much detail because I only have so much time. The key parts of this page are that it has an edit form. Edit form is really cool in Blazor because it's maybe the only control that is adaptive. So it works in interactive mode or in server static mode. So using edit form in server static mode, like normal, you give it the model you want it to talk to, the button or event you want it to handle, but you do have to give it a unique form name. And this value right here can be any unique value. It doesn't matter. But behind the scenes, what's going to get rendered here is an old-fashioned HTML form. So that log or form name is what's used as the ID to identify the form. We get the username, we get the password, we've got our button. So when the user clicks that login button, it's going to run the login user method. And so if I go down here in my code, there's a couple things to point out. First, I've got this supply parameter from form because that edit form is going to be a postback. I would like to get the username and password into some friendly object. And so I've got this user info class that just has username and property or username and password properties. So it maps direct. And then I've got my login user. And so here I know that at the end of the day, what I need is a claims principal. I'm going to use my user validation service to validate the username and password. And I think I promised that I would show you that service just real quick. It's incredibly secure insofar as that it makes sure the username and password just match some values, which you'll see in a minute. There's no security here. I guess that's my point. Really, this code is what you would replace to call your database or whatever. Once I've verified the username and password, I'm going to create a claims identity. I'm going to create a list of claims and load all of those claims. So in this case, I'm saying, okay, here's the username, here's a list of roles. You can put all sorts of other user profile information in here. Then I'm going to create the claims principal based on the identity. And down here, I'm going to call sign in async to sign in the user. And so with all of that, let me just quickly run this thing, and then I'll run the Entra ID one so you can see how that works. And then we'll be done. It's a lot of material to cover in a short period of time.
Half an hour is a challenge, right?
It is. So you can see here I've got the login link. If I click login, for my demos, I always put my identities there. I click login. Yeah, now it says hello admin, so now I'm logged into my application.
That's great. Yeah, we have a question actually from Marvin Klein Music, who is already asked a question before. So this is great to have you on the stream and to see that you are listening and asking. The question is, how would you get the user ID from the logged in user? Oh, I believe we lost Rocky. Okay, so why don't we just do a follow-up, Marvin Klein Music, if we will try to get you the information a little bit later and then to mention it on the show. Sorry about that. So our next guest is Vincent Baaij, and I will talk to Vincent immediately after the small transition. And we are back. Sorry for losing Rocky. I'm not sure exactly what happened. Rocky's in the US, we're in Europe. Everybody's watching all around the world, and the technology can happen. I will try to get the answer to the question a little bit later. So the next speaker is Vincent Baaij. I'm very happy to have you on the show. Vincent, how are you doing there in the Netherlands?
Doing well. Yeah, in the Netherlands indeed. So hopefully you won't lose me.
You're a little bit closer to us, and you're in the same time zone, which is cool. This is great. So Vincent, you are the main contributor for Fluent UI with Blazor, and you are collaborating amongst other people with Denis Voituron, who is one of the co-organizers here. And you are using that to build web and mobile applications. And of course, this is a big project that you are managing as a, how should I say, as an open source project, right? Next to your main activity. And your session is going to be about Fluent UI in Blazor, and it's called Exploring the Fluent UI Blazor Library v5, Next Generation Web Components and Architectural Innovations, right?
Yes, correct. Yeah.
All right.
We have been working on this library for 4 years already. So we have a number of versions released already, main versions, and we are now busy with building the next main version of this component library.
Exciting. I can't wait to see the session, so please take it over.
All right. So yeah, that's the screen indeed. So yeah, as Laurent said, my name is Vincent Baaij. As you can see here on the title slide, I'm now a cloud consultant at Rubicon Cloud Advisor. My first workday there was yesterday, so pretty new there. And up until the end of August, I was working at Microsoft as a cloud solution architect. And well, long story short, I got involved in this project and ended up being the maintainer of that together with Denis. As I have left Microsoft now, that doesn't necessarily need to change anything for this project. So as it is now, and hopefully can continue like this in the future, I will still be contributing and maintaining this library. If you want to reach me on the socials, you can usually find me at VNBaaij or at Baaij.net. Which is both kind of aliases and playful names changing, but you can find me there almost everywhere. So today, it's like what's already mentioned in the previous section. It's only 30 minutes, so I'm not going to go in too deep into building actual demos and showing you code, but there's 3 points that I would like to touch upon today. So first, what is the Fluent UI Blazor library? For some of you, that might be a little bit of a rehash of things, but we still see a large number of new people that are using the library for not such a long time. So we think it's useful to go through those details again and make it clear to everyone where we are. Then I'm also going to talk a little bit about our templates because I feel and think that not a lot of people are using those, but they could really help you jumpstart your next project because everything is then already set up. And the main part, of course, is going into this next version of the library that Laurent already mentioned, our V5 version, where a lot of things are being changed, but we'll go into those in detail. So a little bit about how we support this library. As you all know, we have the .NET 10 release of the SDK coming up in November. So of course our V5 version will also be supporting that .NET 10 release. We have been working on it for quite a bit already, but it's not finished yet, and I can't guarantee or promise that it will be ready when .NET 10 ships. But at least when it will ship, it will support .NET 9 and .NET 10. I think the good news there is that the .NET 9, that support has now been extended, so it now runs alongside and is supported just as long. Instead of 18 months, it's now 24 months. So that's good news. And of course, the upcoming .NET 5 version or the upcoming V5 version will be supported longer than just .NET 10, probably. So let's go into the Fluent UI Blazor part. There's a lot of pieces that are building up this component library, and basically the main players there are the web components. It's the fast component library. It's the Fluent design system, the web components, and of course Blazor. And .NET Aspire is mentioned here on the slide. It's not really part of this puzzle, but it's important to mention as this is the main and most public consumer of our library. So if you know Aspire, the dashboard is being built with the Fluent UI web component library. So first, let's go into what web components are. It's basically just an umbrella term that refers to a collection of web standards that are aimed at creating custom HTML elements. And some of these standards are under this umbrella, like the ability to define HTML tags that don't exist yet, like you can see here on the slide. You can plug it into a standard component lifecycle in HTML. You can also encapsulate HTML rendering, and you can also encapsulate CSS and use parameterization there. And each of these functionalities is defined and standardized by the W3C, and it's supported by every modern browser. So you don't have to do anything special there. Fast hasn't built its own component model, but it uses kind of these mentioned web component standards, and that makes it possible for components built with these standards and which are using the Fast toolset to function in the same way as built-in normal HTML elements like a div or a paragraph. Now, what is then Fast? So Fast is just a collection of technologies that make it easier and possible to build web components. It's not necessary to use a framework that uses to work with Fast components, but it's of course very well possible. And when you combine them with the desired framework or library, it will almost be easier to use them. And since early 2020, there's been widespread adoption of web components, not just by Microsoft, but also it's heavily being invested in by Google, Adobe, Salesforce, MIT, SpaceX, and many others. And if you look at the MDN documentation, then you will see that that whole site has been rebuilt recently with the use of web components. So Fast just makes it easier to compose web components and use the building blocks to make it possible to build those web components. And I think the best way to compare it with is something like Lit, the Lit framework, which basically also makes it possible to build web components. This is just another technology which has been developed within Microsoft and is currently still being used within the web components. Now, if we look at the design of this library, we are using the Fluent design system, or Fluent in short, and the origin of that can be found in Metro, the design system that was being used by the Zoom music player and Windows Phone devices, which I still miss, but a lot we have to do so with. And the system just contains guidelines for the designs and interactions used within software. So it's designed to help developers create web applications or desktop applications for that matter with a consistent and polished user interface which align with those Microsoft design guidelines. And Fluent UI provides then a collection of reusable, customizable, and responsive UI components that are suitable for building modern web and mobile applications. Now, on the previous slide, we already saw that there are some key features that are aspects of the Fluent UI, which include then like consistency, customization, responsive design, accessibility, very important, and integration, and that all in the form of an open source package. So Fluent UI is open source, the React components are open source, the Blazor components are open source, the design is open source, and so it's free for everyone to use, which is of course a good thing, but it's also, I think, one of the kind of defining choices that you need to make on using this library, because the aim is to implement this Fluent design. And if you're building like a line of business application for an internal network or an internal application where you want to have like the Microsoft look and feel, then yes, this is a perfect set of components for you to use. If you want to build the next big e-commerce site with all kinds of flashy things in there, then don't bother, because this is not going to help you. So we have a very specific goal with this library, and it's not that it's not entirely possible to change stuff around and make it look a different way, but we purposely don't expose that too much, because that's not what it's meant for. So putting that all together, basically you have Fast, and the Fast team has built an implementation of the design system with their building blocks, and those are the Fluent UI web components. And these components are framework agnostic and can be used in any modern browser, as I said, but to make everyone's life easier, they're always used with a kind of front-end framework. So that's for the React components, of course, that's going to be React. But the framework we're most interested in, of course, today is Blazor. And that is exactly what we did with the, basically what we see here on the slide. So you have Fast, you have the web components, and you have the Fluent design system. And together that forms the Fluent UI web components. And our current v4 library of the Blazor Fluent UI library is using the version 2 of the Fluent UI web components, which are actually following the older Fluent 1 design. The v3 version of the web components that I'm currently working on is targeting Fluent 2, and that is the latest version of that design system. And we will be using that in v5. So when you use the v5 library, when it's available, you will have the latest Fluent design implementation. And I thought I had do not disturb on, but anyway. So yeah, having those Fluent UI web components then and combine them with Blazor, that is basically what we did, and that gives you the Fluent UI Blazor component library. It's of course not just those UI components. There's a lot of other stuff involved. Later on, I'll show you a slide with a subset of all the components that we have in there. But we also have, for example, the full implementation of all the Fluent UI system icons that are there, which is like a set of 11,000 icons or even more currently. And yeah, we started out as a collection of wrappers of those web components, but it has now grown to a set of over 70 components and services and templates, etc. A little note about support. So I mentioned it already, it is a pure open source project. We are not in any way part of ASP.NET Core, even though that is part of our namespace, but that is purely because we follow that namespace pattern that we have within Microsoft. And when we started this library, we started using that. But we're not part of that. So we don't commit to shipping any libraries or updates as part of the official .NET updates. So it's not .NET 10 is there, then our .NET 10 version will be there automatically as well. We try to aim to achieve that, but it's not guaranteed. Also, it's not supported through the ASP.NET Core repo or support.microsoft.com. So we just have our own repo, which lives within the Microsoft organization. And if you want to have support, you need to provide us with details and open up issues in that GitHub repository only. So please do not try to raise issues on Discord or any of the other channels where we are active, because then we have too many places we have to look at those issues. And yeah, we basically only pick up what is there in the GitHub repository. So far for going with the details about what it is. Now let's zoom in a little bit on the templates that we have, because I think it's, like I said at the beginning, something that isn't being used that much, but it's really, yeah, I think a nice addition. So basically what you can do is if you just start Visual Studio and you say you want to create a new project, you get this well-known dialog where you can see which project you use, templates you've used. But if you install our template package, you can see that there is also going to be a Fluent entry here in this list of project types. And what we have done is we've basically recreated the standard templates that are there, the 4 standard templates that we have to build Blazor applications in Visual Studio. And those are all available in a, how do you say, Fluentized form. So the Blazor web app, the Blazor WebAssembly standalone app, the .NET MAUI Blazor hybrid and web app, which was new in .NET 9, and also the .NET Aspire Starter Kit. Well, they all have Fluent in front of that, so that makes it kind of clear on what they do. It's just 100% copies of those standard templates but with Fluent put in and Bootstrap or any other CSS shizzle that was in there removed. And yeah, we don't try to do any extra stuff in there, just provide you with a all setup template so that you don't have to add the NuGet package. Make sure that you install a style sheet or a script file or whatever. Everything is set up for you already. So that makes it really easy. I'm not gonna do that now, but you can see if you go through our repository that there is now a .NET 10 step that we want to add. And basically what that does is also add .NET 10 templates to this set of templates that we have now. So within the next release, we will also offer any template so that you can say, okay, I want to have .NET 8, I want to have .NET 9, and .NET 10 will be added here to the list as well. And any updates that have been made to the .NET 10 templates, like saying that you want to have a localhost.dev base domain name, I think, that's also going to be present here in these templates. So really useful if you want to start a project with Fluent. All right, moving on. So I said, yeah, already a big list of components, and this is just a subset of that, but this gives you a kind of an impression of what kind of controls that we have. It's not totally up to speed or up to level with what we have on the React side with the Fluent components. We have some extra, they have some extra, but of course there is a large set in the middle, in the cross section of those two, that we both have, like kind of input controls and other components that are just there and which are fairly regular, occurring in other component sets as well. But yeah, you can see the current version of that if you go to this URL. Has all the demos and all the documentation of all the components that are available, and also goes into how you can install those templates. All right, let's move on to version 5. So that's what we've been working on for quite a while already. I think it's already over a year. But yeah, it's like Laurent already said in the beginning, for us this is a side project, so we try to work on it when we can, but it's sometimes hard to find time, and there's a lot of ground to cover to get this version off the ground. So progress is there, but it's going slow, and yeah, we do our best to give you a great new version as soon as possible, but we cannot give you any ETA yet. So like I said, we will be using the Fluent UI Web Components v3. So that is what the Fluent UI team is currently working on. And this will give us more similar functionality to the other Fluent UI frameworks that are there, like the React components that we have. So the underlying web components that we use will align much closer to the Fluent React components. And this, unfortunately, also means that a lot of changes will be made to the parameters, the enumerations, and features. So there will be a lot of changes, and most of them will, of course, also then be breaking changes. So that also kind of warrants for us to go to a new major version. But it will definitely not be install a new NuGet package and be done kind of migration, or implementation, I should say. So you need to plan for migrating stuff over from the V4 library to V5. Like I said, there's also an advantage, and that is that it will use the new V2 design. So that will give us a better and more accessible and more robust set of components. So let's look at some of the fundamentals there. Basically, what we've done in this new C# project and solution is that we kept the same folder structure. But what we did is we split the component library into two different projects. On the left side, you can see here that we have the Razor components. This generates the DLL, the Microsoft Fluent UI ASP.NET Core Components DLL. And then we have a script project, which compiles all the scoped TypeScript files, which are associated with the corresponding components. And we also compile these global TypeScript files, and we merge them all into one one JavaScript file. And we merge all the isolated CSS files associated with the components in a single bundle file. So the main advantage of that is that we're going to have like one CSS file where all the components have a Fluent prefix. And that also means that it won't be necessary to use the Blazor deep keyword anymore if you want to customize some of those components. So that makes it a lot easier if you're using the library, if you want to make some changes to those components and make them respond in a different way. Another big change that we did is with regards to unit tests. We had some tests for V4, but not enough. And we decided to raise the bar a bit for V5. So we said in the beginning, or no, we were actually already working on it, but we said at a certain point in time, Denis and I, like, okay, we're going to have code coverage testing, and we want to have at least 98% coverage. So all those 98% of the lines need to be covered by tests. And we're still maintaining that. We are quite far already in building this out, and we have a lot of components already. And yeah, we have added many more tests than we had with V4. With those tests, we are changing now to the Razor format that BUnit uses. So that makes it all a lot easier to make small tests. And we've also added some global tests. So every component has like an ID and a class and a style. And we've added like global tests for that, so that for each component, those things will be tested as well. So for a lot of those tests, we are using HTML compare mode. So basically each test generates an HTML file. We have a saved HTML file, which contains the expected or result that we want to verify against. And yeah, if there is an error in comparing those two, then we know that there is a regression somewhere and we need to fix that before we can actually commit it to the repo. We've also added our first playwright tests so that we can confirm that the rendered result of the components is correct as well. And our plan is to extend this over time. And also what we did for the code quality is that we've activated a large number of analysis analyzers. And we basically took the configuration from the ASP.NET Core and the Aspire repo and applied that to our own repo. So you will see a lot of patterns that they are using in those repositories in our code in V5 now as well. So yeah, in general, I think we can say that we have a lot better code moving forward. And here you can see an example of such a test where the received HTML file is different from the verified file that we saved before. So it's easy to find where we need to make a change to fix this. We've also completely redesigned our demo project. So we want to make use of .NET 9 and .NET 10 features, but we also want to make it easier to work on the documentation. In V4, all the documentation, or most of the documentation, was done with HTML files. So that made it rather tedious to make changes. And for V5, we are completely redesigning. We have completely redesigned the documentation to use Markdown files. The Markdown files can contain a reference to the Blazor components that we have, like so that you can have live examples in the pages. And yeah, that's quite easy to write that documentation that way. We've also decided to separate the demo examples from the data examples, and we've basically created some sample APIs that can be used. We want to probably do that in the NuGet package, but it makes it a lot easier if you want to raise an issue and you want to use certain data, that you don't have to come up with an example yourself, but you can just refer to the data and the APIs that we have already created and which are available. What we've also started at is a large migration section, and I will show you that in a little bit. And yeah, the aim is basically that we can have like a migration documentation that you can feed to Copilot, and that an agent can then help you migrate an existing V4 project to V5. We will definitely not be providing you with an automatic migration tool, unless some of you in the community want to work on that and make that possible. For us, that's a no-go at this time, because we simply lack the time to do that. But I think with Copilot's help, you would be very capable and would be possible to do a migration without too much work.
All right. Yeah, very exciting. We have a question, or rather it's a remark from a certain John Galloway, who is joking here. I guess it's a joke. He says we can bring back marquee and blink the tags now. So I guess, yes.
Okay.
And then of course, we also want to have some counters who show you how many people visited your website, like we did in the 90s, right?
Yeah. No, but
obviously,
you can never have too much blink in your site, right?
I totally agree with that. Yeah. This is great presentation. So thank you so much for that. And again, right, I do love those, extended projects that the community is working on, who basically extend the functionalities of the in this case of the UI, but of the framework in general. So this is really cool. Yeah, thank you so much for your contribution.
One thing that I want to add there, Laurent, on the fact of the community is that recently, up until recently, Denis and I were the only ones that did all the work on the GitHub repo. But we've added Adrian, who's with you there in the room, Marvin Klein, Pascal and Time, and they are now also helping us on triaging issues, assigning issues, creating PRs, etc. Denis and I still have to review everything in the end, but still, this is really lifting the load off of us and makes it easier to do the work. So big applause to them. And if anyone else is interested, please make yourself known to Denis or mine or me.
Fantastic.
And we can add you.
All right, Vincent, thank you so much for your presentation. Really appreciate the time. Time to take a break because it's evening for you now. So hopefully you can have dinner or a break or anything, or you just stay with us and then you see the other presentations. So thank you so much for coming with us. I want to take a moment to just mention one thing. So Rocky is sorry because his browser basically crashed a little bit too early before he could reply to the question. But I have actually the answer to Marvin Klein's question. The question was, how do you get the user ID of the logged in user using the authentication mechanisms that Rocky was showing? And so the answer is there are actually two ways you can do that. In a component, you can use @context, which is going to give you the authentication context, and then you can get the user information. And the other thing you can do, if you inject the authentication service provider service in your Blazor application, then you can ask this service for the user. So hopefully that clarifies things. And Marvin Klein, thank you so much for being there, for asking questions, and also for contributing to the project like we just heard. So we are going to have a quick transition, and then after that, we'll take the next session with Sergi Ortiz Gomez. All right, we are back, and I'm switching from French to English in here because the production team is actually speaking French, so this is cool. Thank you so much for continuing to watch us. This is great. The next presenter is Sergi Ortiz Gomez. Sorry for the butchering of the name. Sergi, you are based actually in the Philippines, which is crazy because my wife is Filipina. I know the time difference very well. It's like middle of the night for you, right?
Yes.
All right.
So
this is
1:30 a.m. for me.
All right. Yeah, this is a real trooper. Thank you so much for joining us. Sergi, you are a software architect. You are based in the Philippines. And in your bio, it says you worked with VB.NET, which is, you know, those were the days, right? This is how I started in .NET as well. And then C#. I think that a lot of people who do .NET these days use C#. And your session is about pre-rendering Blazor WebAssembly and lazy loading. So I can't wait to hear what you have to say. Please take it over.
Yeah. Hello. Thank you for watch this presentation. I love Blazor from the beginning, really, because I hate JavaScript. Then when I found Blazor, I did developing in Blazor. So one of the most common issue in Blazor usually is the issue about the loading time, right? So with this issue, sorry, with this issue for Lucky, we have the possibility to pre-render Blazor. Also, we have other functionality. Is not common know for the people is about the lazy loading. So the combination between pre-render Blazor plus the lazy loading, we can get the smooth in Blazor. So talk about that, no? Oops, sorry, wait a second. So other feature give us the possibility about the pre-rendering Blazor is improve the SEO feature. So other issue we have in Blazor is about when the robots is still looking inside your website, because all is only one file, all is one HTML file, really is your index HTML. Then how you going to inject the SEO per each page? Have a lot of techniques, but for me, the easier is pre-render Blazor. Usually Blazor always, we need some API, right? So because we need some API, we can already pre-render Blazor. And what is the difference between pre-render Blazor or use Blazor app? Blazor app create two Blazor projects, right? Like the other speakers already talk about that. And then we have to fight in with the render mode, right? But if we are using a full Blazor application standalone, this is the project you need to create, then you don't need to still fight in with the render mode because you are always in Blazor WebAssembly. Okay, so that's why I prefer use pre-render Blazor than still using the new functionality about Blazor app. But it's still almost the same, okay? You can create your Blazor app is your API, and then you can manage your render mode. So what we need to do for solve the headache about the SEO and the first loading, we need to we need to create we will to improve the first loading. We're going to reduce the download size because when it's pre-render, the first render is server side, and while the app is still running, is downloading in the background all the libraries MAUI Blazor for do the WebAssembly. Okay, so until the Blazor app is not full downloaded, it's still in server side, like with Blazor app. And finally, we solved the trouble about the CEO. Then, what is the steps we need to do? The first, we need a server side app. This is our web API, okay? Later, we need our client, our Blazor client is our Blazor WebAssembly. For the lazy loading, we need to define what is the libraries we know going to load in the first render. And finally, we can do some logic in server side of views for the CEO logic, okay? Why we need the server app? Because we need this functionality about we're going to do the request to the server, and the request should be response, and the server is who will render the Blazor in server side and return all the HTML to the client. After the page is already low, then still in the background, loading or downloading the rest of the things we need. Okay, so initially this is the steps to create the web API. I still using minimal API, for example, and then the first we need to do is add the dependencies for the WebAssembly server. We need to add in the builder the Razor pages. We need after the HTTP redirection, we need to use the static file list, because remember, Blazor WebAssembly is like a static file list, right? Because we have the index and other, the CSS file list and any other, right? We need to map the Razor pages, and then after all this one, or before, because really it's a file, we need to add the file should be rendered in the server. This file usually is named host CS.html, and inside this file, we need to add all from the index.html. Okay, so all we have in the index.html, we should be add in this file. Later, we can map the file back, or we need to map the file back to the page, to that page. The page should be my index page. Add obvious, add the reference to your Blazor WebAssembly, and then in the file about my index page is where we're going to add the references for the static content in my Blazor app. Also, it's very important to remind, in this host, we will use Blazor WebAssembly, not Blazor server, the JavaScript file, okay? Because this is who will still in use later when it's already low. When it's already low, the system always use WebAssembly. Then, sometimes you need to take care about the HTTP client, okay? Because when we still pre-render the Blazor, we must be to add all the services we need in the first load, in the first page. This is the only important, okay? All the services we need in the first load, in the first page, all the services have this page should be also registered in our web API, okay? If in the first load, the system don't do any call to HTTP or no, it's not using any service, then we can keep the web API like it's it. But if we are using some HTTP client or we will use some service, we must be to register all in the web API. And then one of the possible issues is with the HTTP client, because when we register HTTP client from the Blazor WebAssembly, how to register is different from the server, from the web app. And this is a small example how to do. But this is only needed if you will do some call to the client side, okay? Also, if you have a strong HTTP client register where he already know what is the address, because possible it's not your web API, it's other web API, so no need. Only need to inject or register the service about your HTTP client strong type, right? So now what we need to do in the Blazor WebAssembly. In Blazor WebAssembly, we need to remove the two lines about, well, really not need remove the two. The first one is the most, the first one is the most important. Remove what is the root component, because the root component now is registered in our host file, okay? And then the head outlet, we can keep or we can register or we can remove. This really is not full important. And if you want, you can delete already the index.html file because it's already not longer in use. Really, the system no will use this file anymore. But I always recommend delete it for not get mistakes later. Then it's time to check what is the DLLs or what is the WebAssembly file is we need to load in the first load, okay? So when we're going to use lazy loading, we need to register in our project what is the file is we going to load after, okay? So if in the first load, imagine we have a big library, for example, I don't know, chart library, for example, for still loading charts, then this library maybe is heavy or is 1 megabyte, 2 megabytes, 10 megabytes, any size. And then we don't like to load this file in the first load for the page. This can be also when you are using only WebAssembly directly, not with Prerender, okay? But the combination is the best, right? So you must be to register in your project with the assembly name and that WebAssembly extension, okay? Why WebAssembly extension? Because this is the file should be loaded in the browser. Then the next, here is a little bit small, but I hope you can see. In the Blazor, because it's the first file should be managed by the system, we need to add additional assemblies, and then in the additional assemblies, we need to check what is the path still in use, and when entering the page, need your library, for example, in the path charts, no, or dashboard, or anywhere where you have the charts. Then is when you add the assembly into the assemblies, because you can get the assembly for the file, telling the system what is the name of the assembly, and then add into the current assemblies. Then what about SEO? Then the same. Initially, the only you need to do with the SEO is create your logic for add the SEO into the page. Initially, this should be directly in the Razor page you created with the host, okay? Also, you can still do it per each page if you want in the Blazor WebAssembly, because if the robot will call directly some URL, this URL should be rendered directly from the server side, and then all you have in your logic about your Blazor page should be rendered from the server. So the logic for create the SEO can be or directly in the host file, because maybe you already detect the path or anything you have there, and then add your SEO, or per each page with the component header, then you can still inject in there what is the SEO for this page. Then let's see a small demo. Let's because initially it's a lot, I already have one project here. Then if you see, I have my API. Then in the API, let me put small zoom here. In the API, I registered all the usings I need in the beginning. I still adding something because I still doing queries with databases, blah, blah. And then if see here is the part I already explained. Sometimes only if you will do some call directly in the beginning, you need register your client like that. Really, I already found other way, but this is the most common. And then well, this is the API side, okay, about my calls I will do later. And here is my fallback. See, I add the Razor pages, I add the host file, and I will show you the host file here. If you see, this is pointed to my API and still using my project for the client, this project, okay? Because inside of this assembly is where I have my app Blazor, okay? This is my component app.razor, okay? And initially, the most important is here, okay? We need to register the WebAssembly JavaScript. Then for show you a little bit how is the client, in the client, I keep it here, my index, okay? Because this is the CSS, and this is all the things I need for the client. And this initially is the same we have here. Okay, that's why I said before, from the index, you can get all you have in the index and copy into here. And then this side and copy into here. Okay. And then all this section is how we need to use in a Razor page, this section. And then this is the two projects I will load with lazy loading. Then in the client side, I register these three. Okay, if you see, I am still registering the database entities. It's not from here because this is from some dependency I have already. I am still loading my Sharp project, and I am still loading my pagination project. And then in the app Razor, let me close, I don't like too much open. In my app Razor, here is my definition for the lazy load assemblies. And then using the navigation, I use this event. and then check the path. If the path is some of these pages, then is when I'm going to load the assemblies I need for that page. For example, for these 3 pages, I only need these 2 extra assemblies. And for these other 2, I need these 3 assemblies, okay? Then the system is very smart. If I enter in the beginning in some of these 2 pages, I load these 2 assemblies, right? And when I will enter here, this 2 is already low. The system only will load one of this one. But if I enter directly in some of the 2 pages, because the 3 assemblies is already low, these 2, when I will enter here, don't do nothing, okay? And well, in this project, I don't have any about the SEO because really I never use too much SEO, but that's all. So let's run the project. If you see, I will run only the API. Okay, I only will run the API component project, sorry. This call. Okay, so let's check this one. How can I put this one integrated here? Okay. Wait a second, here, right. Okay, so this page, if you see, is a normal page. Have a look in the network. When I will click in some of these pages, you can see here now we load what the system needed. In the table, see already load this WebAssembly and this other WebAssembly. Okay, these 2 files, because one of the file is relative to the data I still getting, and the other file is for the table, is for this component about the table. And then when I will click here, see already changed the next one. The next one is my pagination. This small component only load when it's needed. And if you see, feel so fast and so good for me. If we do that action about refresh the page, here you cannot see nothing because it's already low. Then let's delete the data for the page. Application, delete all the data. Then I'm going to capture this one. I need to close because if not, still load already. Something about the browser. So again here, if we go into the network and then we enter directly like a robot, enter directly in that page, is when load, see, when already load what they needed. And then still doing the pre-render, okay? Still doing the pre-render plus the lazy loading, all from the server side. Then initially that's all for me today. If one final thought is, if you compare the minimum project we need, let me show you the minimum project. This should be the minimum project we need, is only the API, the normal API, the minimum API, okay, with the client, because the client is in use. If you see, here I load directly what is the address for my API, and then add the Razor pages, map the razor pages, the fallback to that page. That page is the same. It's just the minimum we needed with the client project here. And then in the client side, what I did is comment these lines. I don't need these lines anymore. And nothing else, because really here is the simple project. Then let's run this project, the web API. And you see, it's still running in the beginning from server side. Then if we update this page, see, all perfectly still loading, so fast, so good. And as I said, I prefer keep the separation between who is the web API and who is the client. Because the advantage about Blazor WebAssembly is if we move this API to, for example, use microservices, and then you have 10 different APIs. If you will use Blazor app, it's still almost the same, right? You can still doing all the calls to your APIs, blah, 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 but you already have code from Blazor in the server side and code from Blazor in the client side. So that's why I don't like too much that. I prefer always, if I need it, pre-render the Blazor. Most of my applications right now, usually I don't use pre-render. I only have my three projects is pre-render already in production. Most of the others always is directly Blazor WebAssembly because in my case, I don't care too much about the loading time. Well, that's all. It's already my time. Thank you so much for attending. Have some questions or anything you can ask.
Yeah, actually, I had a question for you. So I'm wondering, you're based in Southeast Asia, right? This is a region that I know well and where I always meet a lot of developers. How would you say is the ecosystem around Blazor? I know there are tons of web developers there. Do you see some adoption for Blazor in the Philippines, or how do you notice that?
Yeah, for me, I think the adoption for Blazor is still fine, still very good. Right now, I start to doing a lot of projects about open source for myself, and I have requests I have from Facebook asking, hey, how to do that in Blazor, how to do that in Blazor. So I guess Blazor adoption is still ongoing, and when the companies can feel exactly the advantage about Blazor, not only Blazor WebAssembly, also Blazor Server, or inclusive the NET MAUI, right? Because, for example, most of my projects, I already remove all the logic about the views to a shared component, and then it's easy to migrate to MAUI because my client is only the basic for Blazor WebAssembly, and all the views, all the management is in his own library, and then I can easily use in NET MAUI. So most of my projects initially now I still doing always a NET MAUI project plus my API plus my Blazor WebAssembly, because I always have my website, and then the user can have his app in the cell phone.
Yeah, no, that's great. Yeah, and in fact, we are going to talk to Beth Massi in a moment, who is one of the program managers on MAUI. So this is really a very nice ecosystem. Thank you so much, Sergi, for taking the time to talk to us, especially in the middle of the night. Appreciate your time, and thank you for your session.
Thank you to you.
All right, so next on the list is this time Ed Charbeneau, whom I introduced a little bit too early earlier. Sorry,
you scared me to death earlier. I thought I was in trouble.
Oh my God, we had a little bit of a miscommunication in the team between the order on the website speaker page and the order on the agenda page. And so I took the wrong one. So it's all on me. Sorry for the heart attack. So Ed, you are based in Kentucky, right? Are you in Kentucky at home right now?
Yep, that's correct. I work from home in Kentucky, and I'm a developer advocate for Progress Software.
Right.
I've been doing .NET development for about 20 years now.
Yeah, those were the days. I also started in the, well, I guess I started in 2001. So it's, oh my God, almost 25 years now. Yeah, you know, it's amazing that, and I know you have a lot of content. I'm going to let you talk, but it's amazing to think that we have spent 20 plus years working with that technology, and the technology keeps evolving and keeps basically keeping us busy learning, right? It changed so much, but I really love that. So this is really cool. You're also a Microsoft MVP, international speaker. I think, you know, you're very well known in the community. It's great to have you today, and you're going to talk about designing for AI first, natural language UX with Blazor. So please take it over.
Absolutely. I feel like natural language processing is the future of all of this stuff that we're doing now. So let me get my
high coding, like James Montemagno would say, right?
Yeah, and the user interface is really changing along with it. So I feel like the key to all of this is the natural language part. And I'm going to show some demos of not only how that is going to start looking, but how to implement some of this stuff with Blazor code. So let's see if I can, there we go. So I'm going to go back to the era of mobile first for a minute, just to kind of put this in perspective of how big of a shift this is. When I started with Progress Software, the shift towards mobile was already in progress, and we were trying to figure out how to do mobile applications and mobile websites, because we were in this state of pinch and zoom where you had your existing website and you're pinching and zooming to view it in a mobile browser. And I feel like this is kind of the same position that we're in with all of the AI technology when it comes to front end design and development. We're in this pinch and zoom phase where AI first is going to be the trend, just like mobile first was the trend when all of the mobile devices started rolling out. And we're kind of in this limbo state where we're bolting on AI functionality to apps that already exist. And we end up with the opposite side of the spectrum also, where it's an AI first application, and then we present the user with a text box, and they're just supposed to know what to do with this app. And this transitional period is going to be something that confuses users, and it's also confusing us developers and designers. Like, we don't know where to start with the application. Showing the user an empty text box isn't a great experience because you don't know what the app capabilities are. So users have to be able to understand what the application does and how it operates. And then developers, we also have to understand how to build these things. And we're in the very early stages of figuring out what AI first actually means. So the rest of the demos that I have are going to be proof of concepts of what's coming, what are some of the things that are being implemented now, and kind of giving you a trajectory of what the landscape is going to look like. I think part of the problem with all of this AI first stuff is that most demos that you see are showing basic chat completions. So we're just talking to AI, asking it to summarize things, and it's kind of gotten to be this to-do list of the AI experience. So I think it sells the technology short, and it doesn't really give us developers an idea of what the capabilities really are here. So, you know, we get this mode of you're about to show some AI demos. Would you like to start with a chat? And I'm going to try to avoid the direct chat demo and start with a little bit something else, kind of open your minds. Before we get to demos, I want to talk about some of the transitional elements as well. So I said we're in this phase of moving towards a mobile or an AI first type of design. And some of this is taking existing components and adding new features that are AI improvements. And this is to help get users acquainted with AI technology and not completely replace the user interfaces that they're used to. So you see things like the Microsoft Smart Components experiment. And here are some of the AI components that came out of it. So generative AI completions. We all know what completions are like. We use them on our phones all the time when we're typing and texting. And this is an extension of that behavior. And what makes this different than your basic chat completion is you can customize your autocompletes to the context of your application and what activity is being performed. So in this example, we're trying to help assist the user in completing some inquiry about vacation time. And this may be on a form that you're filling out in your HR software, something like that. So we've got the context of the role that the user is in, and we're helping them fill something out. Another example is using vector search. You'll see me do some of this in a minute, where we're taking the meaning of something and searching on the meaning of it rather than verbatim text and keywords. And the way this works is the AI is embedding vectors that have the meaning embedded with them. So we can search on things. In this example, we're searching on, say, dairy, and things like cheese and milk come up. And we can also flip this on its head and say, I want the opposite of this meaning. And that opposite vector of something like dairy might be hot sauce. So these are very powerful search tools that we can use to help enable our applications with natural language. So the large language model capabilities, they go well beyond chat. They can translate text. They can do code generation. We see this with Copilot and James's demos earlier. The power to take instruction and turn it into computer code is pretty phenomenal. So the large language models, their capability to understand natural language and then translate it into something like computer code is something that we can leverage. So when you think about large language models, think about the various inputs that you can have and the various outputs that you can have. You can input code in schemas, you can input text in any language, and you can input unstructured data. And from those models, you can get back code, you can translate text, and you can get structured data out. But these things are not mutually exclusive. You can have all of these things combined and produce multiple outputs on one type of a query. So I started looking at some of the UI components that we were building for the Telerik UI for Blazor. It's a product that I work on, and I'm trying to forecast where the ideas for user experience are going to go next. And I looked at the most complex UI component that we have, and that is our grid component. And it has filtering, sorting, grouping, paging, and there is a huge list of features that this component has. And I thought to myself, if I was a new user and I was looking at this grid for the first time, it'd be nice to just ask the grid something rather than try to, I'll show a demo of it in a minute. I'm missing a screenshot here, but I want to be able to ask the grid what I want from it rather than know where all the knobs and switches are. So that sent me down a path of doing some prototyping. And I thought about, what are some of the challenges here? How do I get the AI to understand what is on screen and how to manipulate it without physically clicking buttons and things like that? And we could do things like feed it the entire user interface, give it all the HTML, CSS, and JavaScript, and that's kind of overkill. We could generate UI code dynamically. I think that's a direction we're heading, but we're not quite ready for that yet. And we could try to do DOM changes directly, and that could be expensive as well. So I thought about leveraging existing APIs that we might already have and lowering that barrier. So again, these concepts of the large language models inputs and outputs are not mutually exclusive. So one of the things that we can do is build a prompt with several inputs and get a structured output. So we'll take the user's query in text. We'll give the large language model a schema of the example of the data that we want back. And then we'll ask it to produce a new response based on the existing JSON data we have, the schema, and the user's query. We'll process all of that and get back an output. And this is a state-based control strategy. And I want to show you that. I'm going to jump out to Azure AI Foundry. And we're going to do an example here in Azure AI Foundry. I like the Azure AI Foundry's chat playground. You can do some nice prototyping with your prompts in here. And in the side, I'm going to create a system prompt. So I'm going to say you are a JSON parser. You will use the user's query to modify values in a JSON format. Only update the values in JSON data. Do not modify properties. And now I have a couple placeholders in here. I have a user query and I have JSON data. And I'm going to tell the model these are specific properties or placeholders that I want it to really understand are key unique properties of this conversation. And I'm going to apply those. And although this does look a little bit like a chat interface, you're going to see in just a minute that we're going to vary from a normal chat because I'm going to give it JSON data. I'm going to say that I have some data and it has a first name and a last name property. I'm going to try to zoom in a little bit more. It looks kind of small on my screen here. And we'll fix my typos, a little copy paste. And I have my JSON data. And I'm going to give the large language model the JSON data. And I'm also going to give it a user query. Notice it's asking for one. I gave it the JSON data. And since I have this query specified here as user query, it's expecting that as well. So I'm going to say the user query is to use the phonetic spelling of my name in Bulgarian. So I've given it the JSON structure that I'd like, and I'm giving it a command to execute on that JSON structure. And I get back in Bulgarian my first name and last name as JSON data. So now I've given it code, I've given it a language translation, and I've given it some data as a query. So I've asked it to do something with 3 pieces of information, and it's able to draw a conclusion of what those 3 elements mean semantically, and that I want to get back some JSON data structured this way. So this is a very handy tool because I can do a lot of things with this. I can give it another user query, and I can ask it to, say, rearrange the name. So we'll go back and copy this, and we'll say user query is swap the first and last name. And it's reverted back to the original format, but it has taken my first name value and swapped it with the last name value. So it's very aware of the properties and the values that are here. And if I were to give it the original JSON data, or sorry, the translated JSON data back and run this query in sync. So I have, this is my JSON data, and then I ask it to swap, it'll retain that Bulgarian, and it has swapped the first and last values. So if I'm putting all of these things in context and telling the AI what to do with it, it's really good at understanding where those belong. So back to the user interface problem. If I have a UI like my complex data grid, and I want to ask it a question about that data grid, how do I get the AI to give me a response? And our Telerik UI data grid has a method in it that allows me to serialize the state of the data grid and give me all of the state information about that grid. And then I can give that to the AI and I can say, this is the state of the UI component, and this is the query that the user is asking for. And then it's going to give me back a new JSON state with the changed information in it. It's similar to what's happening with GitHub Copilot when you're doing coding in your IDEs. So let's switch over to a demo application real quick. And my demo application, it's trying to use, this demo is trying to use some of the AI first type of concepts. And it prompts me with the features that this app is capable of. And we'll zoom in for a moment so we could take a look at some of those features. It says it has a home screen, has a voice input feature that allows users to input voice commands, has a voice output that reads responses using text to speech. It has a basic chat interface, has an RMA assistant, and a data grid assistant. All of these features are using some form or another of that command strategy. So for example, if I'm trying to set settings for this application, I've made this application's assistant aware that there is a state object that has the application settings and a tool it can run to change those settings. So I can do something like this. Let's cross our fingers. It's an AI demo. Let's see. Let me make sure. Is my audio sharing? Can somebody confirm the audio from my PC? Is that sharing? I wasn't asking you, AI. I was asking the moderators. Let's try this again. I'm going to try screen sharing one more time to make sure you can hear my audio. Okay, I have my audio enabled on, I think I have to have it on the Edge tab to do it. Let's make sure I've got the right one. There we go. Okay, if you can share that. All right, everybody should be able to hear now that the app is capable of talking back.
I'm here to help.
What features do you have available in the app?
The app offers several features, including a home section for navigation, voice input for speaking commands, voice output for receiving spoken responses, a basic chat for text-based interactions, an RMA assistant for handling returns.
Can you change your voice?
Yes, I can change my voice. If you'd like to select a different voice for the responses, please let me know which voice you'd prefer, and I can update it for you.
What voices are available?
The available voices are Alloy, Echo, Fable, Onyx, Nova, Shimmer, and Ash.
Change your voice to Fable, please.
I've changed my voice to Fable.
Can you navigate to any features in the application?
Yes, I can navigate to certain features within the application, such as the home, voice input, voice output.
Navigate to the grid assistant.
Navigating to the data grid assistant now.
All right. So a couple things happen there. I have speech to text input for natural language interaction through my microphone. I have voice output being supplied by the Azure AI services that can turn text into speech. And I also have a list of metadata that is being fed to the AI as a set of tools that it can call in response to what the user is asking for. One of the tools that I gave the AI that it's able to execute is the Blazor navigation. So the Blazor navigation capabilities are just being given to the AI as a tool call capability. So if I scroll down into my Blazor code for the main chat interface, which I need to reshare because I had to share audio a second ago. So let me jump back to sharing Visual Studio. There we go. My whole screen should be shared now. I can go to my list of tools and you'll see that I have a navigation tool called Get Routes and I have a navigation tool called Navigate To. And in my navigation tool, I'm giving a description to the AI of what this tool is capable of. And it says that it's only able to navigate to items if they exist as a feature. And if it cannot navigate, then let the user know that navigation wasn't possible. If it needs a list of features that are available in the app. It can go ask for those features. And then I'm going to supply the navigation tool with the navigation manager from Blazor. So it's able to execute the navigation manager. So what this will do is when the user speaks or inputs some text and it recognizes that the user is trying to navigate, it's going to call this tool. This tool has the navigation manager from Blazor and the menu data as vectors. So that vector search that I talked about, that semantic search, it's going to do that because the user might not ask for a page based on the exact route. They might not say grid dash whatever, navigate me there. They might say, I want to see the assistant grid feature. So it's going to do a vector search on the route data that's available and the metadata around it. And that vector search is going to provide back a route. And then the navigation manager gets executed with the exact route that matches that query. So there's a couple different AI technologies that work there. There's embedding with vectors, there's vector search, and there's also tool calling. So back to the page that's being ran, we can see I've got a data grid now. And the data grid has some assistant capabilities as well. This is what initialized me to try to figure out what all of these AI first capabilities were, was this data grid. And again, it has all of these menus for filtering, sorting, paging. I can drag and drop things into the header to make groups. But now with AI-enabled, AI-first approach, I have AI that I can just ask it to do things. And I can do this with voice. So I could say, display values with withdrawals less than 5,000. And then I'm going to hit apply. And it has filtered the amount column by less than 5,000. I can also do things like sort the amounts in descending order. There we go. It's sorted the columns. I can do things like highlighting. So I can come in and say, all right, I've got, let's take a look at some data real quick. I've got withdrawals. Let's look at some deposits. I've got checking deposits. Withdrawals are, let's see. Let's ask it to sort by or group by withdrawals. Group by withdrawals. There we go. Now I can see the withdrawals better. And I want to say, let's, can you highlight the descriptions that have ATM? There we go. Now I can easily see those withdrawals that were based on an ATM. So now I don't have to understand where to click on things. I don't have to know what drop-down menus have what filters and how to use them. I can just interact with the grid using natural language. Let's do something that builds on this concept just a little bit more.
I'm here to help.
Can you show me the RMA assistant? I need to file an RMA. Ah, there we go.
I've navigated to the RMA assistant, where you can proceed to file your return merchandise authorization, RMA. Please follow the instructions provided there to complete your request.
Okay, so now I've got an AI assistant that's going to help me fill out a complex form. So in this scenario, I'm giving, again, the AI the metadata for this form. And what I've asked it to do is walk through the form field by field and give me an AI assistant to help me through the process. And that's what I have on the left-hand side. This is the Telerik chat component, and it is using the metadata for the Telerik form to merge the two experiences together. So it's asking me to get started with an RMA number. I'm just going to type in a random number here. And notice it's filled in the RMA number field for me. So I could also use voice for this. I could say Ed Charbeneau. Let's see if I clicked that correctly. Ed, oops. Ed Charbeneau. It's getting probably a conflict with my mic from either other parts of the app or the streaming. But as I type in things, you'll notice I've got a debug window here. And the debug window is showing the tool calling that's happening. So the AI responds with a message asking for the RMA number. And then as a user, when I key that number in, it's going to call the update form tool and pass it in the JSON with the updated information. And it is only allowed to add information here. If it needs to remove information, there's a separate tool call to do that. So I could say something like, oops, my first or my name is Ed Charbeneau the second, which it actually is. So let's see if it can correct that. There we go. So we should see, it was able to update it without it. Here are my RMA. There we go. So we could see that when I asked it explicitly to clear, it deleted that form field. There is some gray area with these things when they're calling tools. So when I built this, I didn't have a clear form tool call for it. I just had an update form tool call for it. And because it didn't have any way of clearing fields, whenever it felt necessary, it had to clear something out, it would completely clear the entire form and start over. So that would always disrupt the workflow. If there was, say, the user made a mistake and they wanted to go back and fix something, it would completely reset the entire form instead of just clearing one field. So there's some progression in building some of these things out where you need to test some outliers and see what happens if people are entering odd data. So this will continue. It's going to keep asking me for pieces of data as it sees they're not present. So I can enter an email address. And then if this seems a little monotonous, entering field by field everything, that's okay, because it can understand multiple inputs as well. So I'm going to go over to my clipboard where I have completed this form before. And I'm just going to paste in the entire thing. And this is the summary I got last time. I'm just going to paste the entire thing in. It says, here's a quick summary of the information provided. It has all of my info. I'm going to hit submit on that. And it's trying, but I think that form field might have messed it up. Let's try that one more time. There we go. It got it. The validation was blocking it. So I can paste the entire thing in and get the whole form filled out if it has enough context to make or draw a conclusion from that data. So now it says, this is done. Would you like to submit? Sure. Go ahead and submit that form. And you'll see at the top of the screen, it has submitted the form successfully. And if we look in the debug log, you can see it's triggered the onSubmit handler in that Blazor page. So all of the tool calling for this page, we go over to assistance and look at the source code for this. You'll see it has a big prompt here, and it tells the AI of all the scenarios that are happening here. It's actually fairly generic, and you can use it on multiple types of forms. But it has an onSubmit handler tool, and it's literally just giving the AI the access to the onSubmit button code that the user would normally click to initiate. And it's the same method, it's just called by the AI instead of the user. And it does form validation also in case there's an issue. So we could come back and we could cause an issue here. And we could ask it, please submit.
Awesome. Wow.
And it's got an error submitting and it can't. One last thing before we end here is something that you might find interesting. We'll go ahead and clear the entire session out. Because this is built using natural language interface, I can paste in the entire session in a different language. So I went to the translation feature and asked it to translate into German. So if this is not German and it's not correct, I am sorry, I don't know German. I just asked for a quick translation, but I'm going to paste in the German version of the data entry and hit submit. And look at that. It's able to connect the dots and put the German version of that data into the right text boxes. And it's doing that because of that semantic capability of the large language model. It has the semantics of all the different languages. And since I listed things like serial number in a different language, even though it's in German and the field is in English, it can draw a connection between those two things and say, okay, this data belongs in this field. It's pretty
amazing.
Stuff.
Well, this is really, yeah, it's pretty amazing stuff. This is really pushing Blazor, to do additional stuff, right? And this is great. We're already at time. I would have tons of questions, but I guess we'll do another session another time. In any case, thank you so much for presenting. We want to go to the next presenter already because of time. And by the way, to our viewers, we might have lost the connection for a short moment. Sorry about that. But we do have recordings and everything, and so we can publish that. Thank you so much, Ed, for participating today to BlazorDay. Always a pleasure to see you, and see you next time.
Thank you very much. Take care.
And we are back. We still have a few sessions to go, and this is really exciting. We have, Johan is going to be next. We still have Beth Massi, who's going to come to talk to us about hybrid applications, and then we will also have a little bit of a surprise at the end. So my next guest today is Johan Smarius. Johan, welcome to the show. You are based in Netherlands, right?
Yeah, I'm from the Netherlands.
Amazing. This is great to have you here. In your bio, it says you worked with .NET since v1.0, and I noted it down because I did as well. And again, right, like I was saying before, it's amazing how .NET has evolved. And to be honest, I would have never thought that, 25 years later, we would still be working with the same technology, or a very different technology from when we started, because even though the language is the same, I think you can confirm that it has evolved so much, right? So this is really, really cool.
Definitely.
So you're going to talk to us about, oh, sorry, go ahead.
And not just .NET, of course. If you look at, the same applies for me for Blazor. I used it since the preview versions, and it has evolved a lot.
Yeah, that's true. That's true. Blazor, like I was saying in the opening, right? When I first saw it, I thought, okay, that's cool. It feels, okay, it's something new, but it's amazing to see. And when you see what Dan was presenting earlier, right, the amount of components, that they add to make our life easier for authentication, for metrics and observation and everything. So this is cool. So you're going to talk to us about a subject which is dear to my heart, which is clean architecture, specifically for a Blazor application. Can't wait to hear what you're going to show us. Please go ahead.
Okay, thank you. Okay, welcome. Let's simply move on. Well, this is what I already did. I work for a Dutch consultancy company, and I work as a coach trainer for my own company. But that's not what we are here for. When I was prepping this talk, I thought, well, okay, we're going to talk about clean architectures in Blazor. And yeah, I worked as a university lecturer as well. And I thought, well, okay, I can make it a lecture and bore you probably to sleep in the next half an hour. But I thought, well, let's not do that, because let's do it a bit differently. Because once you start creating a Blazor application, it comes with a default architecture where a lot of code is simply in the code section. Okay, so let's go from that point and see how we can migrate to a clean architecture? Well, and there are a number of clean architectures. And the easiest one is the onion. So what we're going to do is we're going to move part of the application to an onion architecture. And then we're going to move part of that application again into a clean architecture. Simply to show you as well that a decision does not have to be set in stone. You can always upgrade an architecture if you notice that things don't fit anymore. Okay. But once I came with this setup, I thought, well, okay, we're talking about an application migration, and what should we do? Well, I thought, well, okay, next to being a developer, I'm also a medical first aid volunteer for a local charity, and we needed a planning application. And just like James, I thought, well, okay, what am I going to do? Well, I'm simply going to vibe code it in Blazor. And that's what I ended up with. So let's give a short demo of what the application looks like that we're working with. I already booted it up because I don't want to spend time waiting for the application to start. So it has one page, an events page, and there are already some events on it. And what I can do is I simply can create a new event, simply do BlazorDay. Typing is not always, well, we're going to do it online. Don't know why I would need first aid for that, but it's today. Okay, leave that one in, give a contact person and give a phone number. There's no validation on it, so don't worry. Put in my email address and create the event. Okay, just wait for it. Perfect. And then I'm going to say view the details. And what I can do is simply say every event is made up of shifts, and by default, an event is fully covered with one shift. I can simply say, well, I'm going to assign myself to this shift. And that's it. Okay. The functionality is not that important. It's, of course, more like what we have to do with it in an architecture. So let's simply close this one up and get PowerPoint out of the way. What got created? And as I told you already, I did use GitHub Copilot for this. In Visual Studio, of course, 2026 Insiders Edition, because I wanted to try it out, what it could do in Visual Studio. So if you look at the design that was generated, it's probably quite familiar if you have some experience with Blazor. So I have my models, my event, my shift, my staff, all the things that I care about. The data. Okay. I did instruct Copilot to start using Entity Framework, and it did come up with this solution, and it works. It's interactive server, so it does work. Of course, it doesn't have its downsides. And it generated something called a service. And it probably started inventing that because I put in clean architecture as the project name. But if I look at the services that got generated, they're more like repositories than anything else. Okay. And then, of course, if I look at my components and I go to my pages and I go to my events page, and now things are getting... No, it doesn't do it. Sometimes it works, sometimes it doesn't. That's the downside of using the insiders version, but that's fine. Okay, what you will see in create event. The event service is used to create an event, and the shift that is needed is created in the code section. So a lot of orchestration is done here. And if I look at the events edit, and then I'll simply go directly for the save event because I know that it's not going to find anything in it. Now, what it will do is do all the validations for me before calling the service. So there's a lot of business logic hidden in my code, which makes it kind of difficult to unit test Yes, and I could say, well, okay, I am going to use Playwright, for instance, to test this application. But I really like unit testing. And yes, I do like UI testing, but as an addition to my unit tests. So this is not really a very good maintainable solution in the long run. And there's also another downside, which was mentioned during this day. What if I would switch this model to WebAssembly? Well, this will not work if I run the same code in WebAssembly. Then I would have to change this and make sure that it's a web API call. And that does hurt. So let's shift back a bit to my presentation. Because in the default architecture, what you actually saw is I have my user interface. I've got some kind of business logic. And in there, I have my infrastructure code, my database, web services files. And if I look at it, things that change a lot is just in the core. And what happens if I change the core? I do have to retest everything on top of it, of course. So that's not really what I would like to have in a good application. At least an application that really needs it. So this is not a new problem. And a lot of smart people, way smarter than I am, started thinking about this problem and came up with all kinds of architectures. And they're all called clean architectures in some way. And the first that I'm going to show you is the onion architecture, because this is the most simple one. And what are the design philosophies around it? Well, separation of concerns, extensibility, testability, UI independency, so that I can switch UI if I want to, and that I can switch external components, like a database. Okay, but what does it look like? Well, the name onion does come from its structure. It looks like an onion. So if you look at it from the core upwards, in the core you have your object model. Okay, perfect. Doesn't change that much. I have my object services. So the services that will make sure that my object model works. So a piece of composition, orchestration will happen there. For those services to work, I probably will need something like a repository. So the interface to that repository is stored here. Then there's a layer called application services. And I use this architecture a lot, but to be honest, I have hardly ever used this one. In the default, you always see the iUser session that you could store something application specific here. But I must say in most applications, I don't need it. And that's fine, because then you don't have to implement it. And in the outer layer, there's my user interface, which can be my Blazor app, that can be a web API. And there's my infrastructure with my database, my file, my web service, and of course my tests. And what is the beauty of this? All dependencies run from the outside to the inside, and you can skip. I don't know who of you know about the layered architecture. I've written a lot of applications using that architecture. But the downside is you weren't allowed to skip a layer. So if I had my controller that needed to fetch some information from the repository, didn't need any business logic, still had to go to some kind of service to get there. Which meant that all the information, all the code in the repository that should be exposed to the user interface was duplicated in that service. And that was a lot of code. Okay, what does this look like in code? Well, let's find out. Switching back to Visual Studio and switching back to my onion architecture. And now it will probably say that it's some pages can't be loaded anymore, and that's fine. Put all the different into different class libraries, simply to make them separate. So I start out with the domain, and in the domain, everything that was in my domain happened here. And if you look at it, if I look at what kind of dependencies I have, well, there's only the dependency that I added for logging, but it doesn't know that it's being used as part of a Blazor application. So I really love Blazor, but for instance, I also really like MAUI. I could use the same class library for my MAUI project. Okay, what's in my domain service? Because that was the one on top of it. Okay, there's my event service. And there are the interfaces that I need for my repository. And I also put in an interface specifically for sending out emails. Because once a shift gets assigned, or if an event gets confirmed, you will get that an email is sent. So that's what I use the email service for. So if you now look at the event service, you will see that the repositories get injected, the email service gets injected, and all the validations that need to be done will happen in this code. All kinds of updates to the object happens here, adding shifts happens here. So all the orchestration nicely happens here. The same goes with the update event. The checks happen here. I do some validations, and I do update and send out the email. The event domain service normally should not be part of this, but I kept it in. And why did I keep it in? Just because Copilot did suggest it. And that's why I wanted to show you this. If you are using AI, GitHub Copilot, or any other AI for this, always make sure that you understand what is being generated, because what it did, and it's not that bad, of course, is it created a method for apply changes so that it will simply push the different changes to the existing object and make sure that we get the right status so that you know when to send out an email. Okay. What does this look like in my clean architecture? If I go to my components, if I go back to my pages, and if I go back to my events, and if I then go back to my, and not the save event, but the create event, you will see that I only use the injected event service and call the create event on it. And for the rest, this is simply UI stuff. So my code in the page is empty. I can really easily, if I wanted to, start unit testing this one. Time doesn't allow it, but otherwise I would simply do it. And the events, well, of course, I can easily now test this with a tool like Playwright, because what do I have to do is make sure that the event gets created and that I do see the event in the list, which is easy to verify. And if you, for instance, go to the edit event and I go back to my save implementation, you will see the same. All the validations are gone. The validations, if there's a domain exception, it will be caught, and all the business logic is nicely separated. Okay, this is nice. There's one downside to this one. You can imagine now I started migrating from the default structure into an onion architecture. And if I now look at my event service, I only migrated 2, and am I already at 122 lines. The downside of this approach is that the services can become quite large. So that's a thing to worry about and to keep in mind. And that's why this is not the only architecture that is around. Okay, because a different one created by Martin resembles quite a bit the Onion architecture for layout, but it does make sure that the responsibilities are a bit differently. So in my core, I have my entities with the enterprise business rules. On top of that, I have use cases. And I guess that most of you are familiar with Scrum and with at least reading use cases. In the green one, there's an interface adapters, where there are controllers, presenters, but also actually translations between the things that the use case uses internally, the entities, and the things that the outer layer needs. Because one of the things that the clean architecture says, do not pass entities, for instance, from the use cases directly to the controllers. So there should be some mapping in between it. And if you look at the flow of control, and it doesn't apply anymore that much, but I took the original picture from it. You get a controller, you get an action, you get to the use case, you go to the presenter, and the presenter displays it on the screen. One of the cool things, and that same applies for the Onion architecture, if you look at the things that change very often, they have been put on the outside. My database, I use Entity Framework. Well, Entity Framework changes every release of .NET. Blazor changes every time, happily, with every release. The entities and use cases that I have don't change that often. I have some applications that I maintain where the entities and use cases have been the same for 5 to 6 years. And that's fine. Okay, but how does this look in code? Let's switch back to Visual Studio and go to the clean architecture. And there's one thing that I deliberately didn't do, but you don't always need that. So what I did for this presentation, deliberately kept it to the plain clean architecture, where you simply start using the use cases. So my domain switched to entities. My application, at least my domain services, switched to having use cases. And for this step, I left the event service in because I wanted to show that you can migrate from one to another. So I have here an event use case. And I created a method execute on it because it really wouldn't be that good to have the method named create event anyway. And the rest of the code can simply actually be migrated. And the same goes for my update. It simply has the same code, but not entirely. There's one thing different. What I already said, you don't pass entities to your callers. So everything I have put it here in my data adapters. For the event and for the shift that I expose, I create the DTOs. And yeah, if you create a DTO, a data transfer object, you do have to provide a mapper for it to and from the event. Okay. And you wouldn't be surprised that if we now look at my pages and I go to the events and I go back to my create event, not that much changed. So I have my use case that I inject, that I execute. And there's one very good thing about this one. If I want to write unit tests for my create event use case, it's just this method. So my unit test will also be limited to only a few test cases, which is great. So the big advantage of this is that you have a better separation of concerns in the use cases. But I'm also an agile coach. And yes, sometimes I work as a scrum master on teams as well. And normally you do teach people to split out use cases on very thoroughly. Normally, I would say, please don't do that, because you don't want 100 different use cases in this class library.
Mm-hmm.
Okay. Given time, we're going to round up a bit because we do have to keep on schedule, and that's fine.
Appreciate that.
There's nothing wrong with starting simple. I know it's quite tempting if you look at some source code and some articles on the web. Oh, everybody is using a clean architecture with CQRS. We're going to do that. Yep, but if I am only needing a very small application, please don't do that. You're only hurting yourself, because the extra layers of complexity are there to do things for you, but they will only limit you in your ability to move forward if your application is far too simple to actually make them legit. What I hope to have shown you is that you can always migrate to a clean approach. Okay, if you really want to go to a CQRS approach, then things will get quite difficult. But even for this migration, GitHub Copilot can help. But as was mentioned today a few times, do not forget to branch, because GitHub Copilot will mess up. I don't know how many times that I reverted a branch simply because things went wrong and I wouldn't get the correct answer. My advice is, do not over-engineer, please. Use the abstractions that you need and choose an architecture that fits your needs. But do keep in mind that an architecture, if you're using the Onion or you're using the clean architecture, will benefit your Blazor application, specifically if you want to have an easy migration path between server and WebAssembly. Okay. I think that we still have time for a few questions, but I'll wrap it up and then I'll give time back for the answers. I will share the sheets.
Amazing.
If you want to. There's a literature where you can always see different things, and here's my socials if you want to get in touch with me. And now we do have some time for questions, I guess.
Amazing. This was a great presentation, and I completely agree with many of the things that you said, especially about starting simple, not over-engineering. I guess this is all stuff that you get from experience, right?
Yep.
I hear there is a question in the chat. I don't see it quite right now.
At Charbeneau,
Okay.
can AI do all the things?
Okay. So Ed Charbeneau is asking, and in fact, the question is on the screen right now. I'm going to come a little bit early, a little bit closer. Can I AI all the things? Well, I guess AI can help, right?
Yeah, AI can help. I'm not fully into vibe coding. It's not that. Yes, I did intervene, and yes, some of the things, if you look at the code, I think, well, okay, I left it in because it was vibe coded, but also as an experiment and as a showcase that vibe coding does not always produce very nice code. So will AI be able to help? Yes, but I would definitely say hook up some MCP servers with good references so that it knows what to generate, because let's be honest, what is it trained on? Well, GitHub. How many different implementations are there for the different architectures? A lot. So which one will it pick? So if you want to let AI help you, make sure that you give it enough prompting information so that it knows in which direction you want to go.
Yeah, no doubt. No, I do strongly believe that AI is a great help, helps you getting started, helps you understand some concepts, these kind of things. But at some point, it's probably important to also understand what you're doing, right? And the learning from AI, yes. I mean, I see all the times that it proposes me some new construct in C#, for example, which I didn't know you could do, these kind of things, some simplifications and all that. But I feel that having an understanding of what's happening behind the scenes and the different components, etc., is also a critical part of building applications.
Yeah, and
All
that's
right.
why
Well,
you
this was
see.
fantastic. Fantastic. So thank you so much, Johan, for joining us from the Netherlands. I will allow you to enjoy your well-deserved evening. And thank you so much for presenting. See you next time.
Thanks for having me.
All right. All right. And we are back. We have 2 more sessions to go, I believe. So this is really cool to see a lot of you online and following us. And we see the numbers staying very stable, which is really great. It means that hopefully this is helpful for you. So now we have another one of those persons that I don't need to introduce, I guess, but I'm going to introduce you anyway. This is Beth Massi. Beth, my friend, it's so good to see you. How are you doing?
Hey, Laurent, it's so good to see you too. Thanks for having me on the show. I really appreciate it.
Absolutely. We're excited to have you. So, Beth, you are in California, right? Is it
That
where
is
you are
correct.
right now?
Yep, I'm in the Bay Area of California right now. It's a little bit warm. It's nice.
That's great. I love to see the on-air signs from Channel 9 on your...
Yeah, right. Yeah, that's like the old times, old studio back in the day when they called it Channel 9. Now it's DevRel, but yeah.
Nice, DevRel Studio, exactly. Yeah. Yeah, I have my signature on a few of those in the DevRel Studio. Always nice to see. So, Beth, you are a Microsoft product manager. You work on the .NET MAUI team, right?
That's
and
correct.
You work, of course, closely with amazing people like James Montemagno, who was on the screen before, and also, of course, all the MAUI people, David Ortino, and everybody else. So you're going to talk about building hybrid applications with .NET MAUI and Blazor, and that's an interesting topic because we've had a lot of different topics which went in very different directions, and this is really what I like about .NET and about Blazor. I mean, we had some things about AI, we have some things about clean architecture and some UI and some discussions about authentication, etc. And now we go rather direction hybrid and also mobile, right, with .NET MAUI and everything. So very happy to hear what you have to say. So please take it over.
All right, I think I got my screen shared here. I've got a couple slides and then we'll get into some demos. Cool. All right, so my name's Beth Massi. I am a product manager on the MAUI team. My main responsibility, though, is taking care of MAUI hybrid applications, which includes Blazor, but it also includes other JavaScript front ends as well that you can use in your MAUI apps. So we'll talk a little bit about what hybrid apps are, a little introduction to MAUI. I think you all are very familiar with Blazor, but maybe this kind of like approach might be new for you. So let's just kick this off. So .NET developers, as developers on the .NET platform, we have choices when it comes to client app development. And the route you take kind of just depends on whether you want the most reach or you want like the deepest native experiences. So on the .NET stack, we have, for the web, we have Blazor. And as you all know, Blazor lets you build these fast interactive web apps really quickly with C#. But then there's .NET MAUI, which lets you build cross-platform native desktop and mobile apps, okay? When you can do this all with a single code base. You write your code against the MAUI APIs, and the framework takes care of translating all of that to each separate device platform. Now, but this is a sliding scale. So depending on your application's needs, you can choose the right mix for you. You can go fully web for the most reach. You can go fully native for the richest native experiences, or what I think is the best of both worlds, you can go hybrid. All right, so today I'm going to talk to you about building hybrid apps that blend the best of Blazor and the best of MAUI, which I really think is best of both worlds. So first, if you're not really familiar with MAUI or haven't really been keeping tabs on the MAUI ecosystem, here's some investments that we're really making for .NET 10. Okay, so I'd say this .NET 10 wave. Some of these things have been released in Visual Studio because we also take care of the tooling inside of Visual Studio and VS Code to build MAUI apps. But then we also have a lot of platform, the SDK. We have core components. We have a lot of stuff that we take care of in the MAUI team. All right, so some of these investment areas are kind of in the release candidates. Release candidate 1 I'll be showing you today, which is generally out there. General availability will be on November 11th at .NET Conf, so I hope you all watch .NET Conf on November 11th. On this slide, I've highlighted some of my favorite features coming that will really help improve MAUI hybrid development, like Aspire support coming to MAUI apps, as well as some work we've done on the Blazor and the hybrid web views themselves for like more granular control in advanced scenarios, which I will show you an example of later. I just want to call out to our partner Syncfusion, who have really helped us accelerate the work that we're doing on MAUI. They've released a set of like free controls for .NET MAUI developers. There's more than like 30 of them available. And they've released them over the course of the year since we began this partnership. So they are core contributors to .NET MAUI itself. They release every couple months or so. They help actually in our public repositories, like helping triage, making pull requests, fixing bugs. So you'll notice a lot of Syncfusion, folks from Syncfusion in our repositories. What's really incredible is since we started this partnership last year, they have contributed over 60% of the community pull requests in the .NET MAUI repository. So that's really been a big accelerator for us to start partnering with key contributors and partners in the ecosystem. And you'll probably see more coming on board as well. So here's just a couple stats from from the activity that we had for the increase in our developer base, more issues or less issues were created and more were resolved, and a lot more pull requests have been merged between the delta between .NET 8 and 9 and 9 and 10. So this is like the year over year from GA to GA. Okay, so 10 is not quite released yet, so it's up till today. So just to kind of give you a sense of how much we've improved building the product out in the open with our partners. All right, so that's a little bit about MAUI. And if you weren't really familiar with MAUI, I hope this gives you a little bit of a spark to go check it out. What we're going to do today is we're going to not concentrate on the native control stack. We're going to concentrate on hybrid apps. So let's just talk about what are hybrid apps themselves and why would you care to build them. So hybrid apps are really just a blend of both native and web technologies. The core of the UI of the application is written in web tech, like HTML, CSS, JavaScript. Okay, these apps are then wrapped in like a lightweight container. That's a native container. And that allows these apps to leverage certain native platform features and device hardware, like camera, calendar, push notifications, things like that. Sometimes a web application can't access these things easily or even at all. And so this approach allows hybrid apps to run on, for example, both iOS and Android without the need for completely separate development. And then it can be downloaded and installed through the app stores, just like you would expect. The main advantage of hybrid apps is that you can achieve better productivity and code reuse across web browsers and devices. So a couple examples outside of the .NET ecosystem is like Electron for desktop apps and Ionic for mobile apps. So what does it mean when we say a .NET MAUI Blazor hybrid app? Okay, so with .NET MAUI, Blazor apps can run natively on these devices as well. Okay, so that means you create hybrid client apps, which combine Blazor and MAUI components together into a native application. And then that gives you full access to the native platform capabilities. So Blazor Hybrid relies on MAUI for the native container and native controls if you want to use them. So actually, you could even mix and match web UI with native UI if you wanted. You could go crazy. It's not as common, but you can do it. So you host these Blazor components in what's called a Blazor Web View control. So it's just another control in the MAUI stack. That derives from the platform web views. So in the case of Windows, that's Web View 2. So the platform web views themselves, and then the Blazor Web View control inside the MAUI abstraction layer is what you're basically using, okay, to render this render your UI. Now, no internet is required for the UI. The UI itself is actually packaged with the app. Okay, so you can use all the built-in, input controls, validation forms, everything that Blazor gives you right out of the box. That stuff is all packaged up with the app. Okay, so this makes it easier then to share your Blazor components across the web and native hosting models. And in fact, we have this solution template, which I'll walk through you really quickly, to get set up really fast with a MAUI Blazor hybrid and a web app, okay, that shares all of its UI. And it's just called the MAUI Blazor web template. And I'll get to that in a second. All right. I should probably mention that the Blazor hybrid apps, they really do have full access to all the MAUI abstraction layer and those native devices, as you can see in this diagram. So the control itself, the Blazor web view, is at the kind of like just one of the many controls of .NET MAUI. And you'll see .NET MAUI is really an abstraction layer that includes controls and APIs. And so those APIs you can, make phone calls, you tap into the device sensors, the cameras, file system. Those are device specific functions. Okay, and then as I mentioned, you can take and package this app, whether that's the Microsoft, Apple, or Google app stores. Okay, so that you can get different types of reach that direction to the mobile apps, to the mobile devices. Okay, also I should mention, like I said, the MAUI supports other JavaScript frameworks as well. So like the Blazor web view, the hybrid web view is also another MAUI control that you can use that provides the interop between C# and JavaScript code. So no matter what front-end framework you're using. So you get all the benefits of hybrid apps I just talked about, but instead of Blazor, your web UI is your favorite JavaScript framework. And this can be handy if you already have a JavaScript web front end. And then you want to just bring it to native devices too. All right. One customer, I want to just call out an example that uses Blazor Hybrid and also has web apps. So they have a set of components that they share across, like I'm describing. This is just My Ride K-12 from Tyler Technologies. So they have native devices and web at the same time. So they have over 2,500 clients, which are K-12 schools across US and Canada. And this mobile app has over, 750,000 downloads, probably more at this point, on both the Google and Apple stores. What's kind of cool, it lets parents track the student bus routes and things like that. But I think what's really cool is they were a pretty small team of just a few engineers, and they've produced some pretty incredible results. So then when they make an update, it goes out to all platforms, which then reduces the cost maintaining multiple UIs across the native and the web apps. So it's a really good customer story. So how do they do this, right? So what does this architecture look like? So when you want to share your UI across your Blazor apps and your MAUI apps, you can structure your solution to maximize code reuse by using a shared Razor class library. And what that does is it just houses the shared UI as well as interfaces for the functionality you want to use on the UI. And then the implementation of those interfaces are defined in the Blazor web and the MAUI projects. And this is because sometimes you need to write different code for the different hosting models, whether that's a native client or a web app. And this gives you a nice clean way of doing that. I think we were just talking about clean architecture. I just caught the last tail end of that talk, but this is a clean way of doing that. So using this .NET MAUI Blazor hybrid and web solution template, this automatically sets this up for you. So it sets up that shared Razor class library and shares it across both the projects. Okay, I'll show that in a minute. What I do want to say before I get to the demo is just kind of give you a little bit of highlight of some investments, some features that are coming in .NET 10. Some are here in RC1, some are coming in RC2. So we're continuing to improve our Blazor hybrid tooling experiences, including things like we're updating the MAUI Blazor web solution template. I'm going to show you to pull in all the new features that are available in Blazor web apps. That'll be coming in RC2. There's also a lot of Razor and hot reload improvements in Visual Studio and VS Code. I don't know if Dan, showed you some new stuff this morning, but we've been working really hard on a lot of tooling and improvements there. And you get a really good tighter inner loop for design and development. For .NET 10, we're also adding hooks so that you have more control over the Blazor web view, like intercepting and handling web requests, which I'll show you a demo of that in a minute. We're also adding the same finer grained, methods to both, the hybrid web view and the Blazor web view, so you can handle these events related to web requests and responses, and generally having a similar API between the two controls themselves. So a lot of little fit and finish work that we didn't get to for hybrid web view in .NET 9, we're finishing up in 10, like packaging like the hybrid web view JavaScript files into the NuGet packages, just like, you know, make it as easy as you possibly can, like Blazor does already. Now, if you're already using Blazor, then you probably won't even notice a lot of this fit and finish work because it's more along the lines of the hybrid web view. But we wanted to finish that, and those two controls now inside the MAUI have a very similar like development experience. All right, so now that we're nearing RC2 release in October, I think it's October 14th, we're focused on like laser focused on fixing bugs and the home stretch. Okay, so I'm hoping everybody is like trying it out and giving us your feedback so we can really like pull off a very amazing .NET 10 release. Okay, so let me just get into a demo now. I'm gonna kind of walk you through this template. So let me get over to Visual Studio. Now I have Visual Studio 2026 Insiders. Okay, so this is I think we released it in August, right? An Insiders release, and so this is like the new bits for you can download yourself. So I encourage you to try Visual Studio 2026, which will also release at .NET Conf. All right, so when I select Blazor Hybrid as our templates, you'll get two choices. One is just a one single project that is a MAUI hybrid app, okay? And you put everything in the project. So it's just a client app. What I wanted to show you today, though, is the solution template, which sets up that shared Razor class library. So I'm going to select that one. I'll just add it in my app. Okay. And what you get here, I'm going to .NET 10. I'm going to show you .NET 10. What you get here is a choice in on the Blazor web app that it's going to create. You can choose your rendering modes. Okay, so it gives you those options. If you select WebAssembly or Auto, it's going to actually create 4 projects: the MAUI app, the shared Razor class library, and then what you would expect, your Blazor web and your Blazor WebAssembly apps. Okay, I'm just going to select server, so it'll just create 3 projects. We won't create the WebAssembly app, but note that it is an option. So if you do want to have WebAssembly as well, you can in the same solution. Okay, so what this is going to do is it's going to glue all of this together for us. Okay, you'll see that it created. Here's our shared Razor class library here. And this has it's referenced by both the MAUI app, which is up here, and the web app, the Blazor web app. Okay, so it hooks all that stuff up for you. If you have never seen a MAUI app before, this is sort of like a MAUI hybrid app is sort of a combination of a Blazor app and a MAUI app together. So you'll see root in here, the index HTML, and your basically the way you style the app would be exactly the same as a Blazor app with CSS. You'll see some components, but you'll also see this folder called platforms. This is very common to MAUI apps. Like you might need some platform specific code. So you'll see that platform specific code here. You'll see all your shared resources like app icons, fonts, images, raw splash screens, that sort of stuff is all in here. And then everything, MAUI will take care of taking those resources and basically building them for each of the different device platforms. But note that if you do need device-specific code, you can write it here. Okay, so that's that. In the case of this hybrid app, the way that we are showing our UI, the UI is all contained inside, in this example, the UI doesn't have to be, but the UI here in this template is all contained in this shared Razor class library. So you'll see the layout here, you'll see our pages, and you'll note that here is the, this is the control I mentioned, the MAUI control. So there is one piece of XAML. So MAUI's UIs are typically written in XAML. They don't have to be, they can just be all C#. But we've got one control. So this is the only XAML we have in our app. Okay, everything is coming through. You'll see the shared, right? Our shared Razor class library. Here's the roots right here. Okay, so all the pages are here. Same thing with the web, the web app basically has a reference to the Razor class library. Okay, and so the only components left around here are some like the error page and not found and things like that. So what I'm going to do is I'm going to configure these startup projects just to load both of them so you can see them running at the same time. So we'll just do that, and I will just go to Windows. Note that Visual Studio also supports Android as well. So I will show that in a minute in my next demo. But just to get this rolling really quick, we'll just show you the web app and the Windows app. Okay. Now with Windows, we're using WinUI at the base. Okay, layer is WinUI 3, and web app's just the web app. Okay, so here it's getting going. Now there's so you'll see sort of very similar code to like the Blazor, like how, when you get started, like the weather, the counter, that kind of thing. Actually, here it's over here. Whoop, let me bring it over. I'm on the screen. There's the hello world. Here's the counter. We said server interactivity. So there you go. There's the weather. You'll see this is the WinUI app here. Same thing. You'll see interactivity. Now Blazor hybrid or MAUI hybrid apps are always interactive. Okay, because you're on the client. There's no concept of SignalR or anything here. Everything's happening right here. Okay, but you will see that we have the same exact UI, but you'll notice there's a slight different implementation detail here, where I'm just displaying I'm running on web using, I'm on a Windows box here in Windows NT. And you'll see this one says I'm running on desktop using WinUI. Now it's the same exact Razor class library, but we have two implementations of the message here. So how do we set that up? How do we do that? Now this is the common pattern you're going to use to if you're going to share UI and create different implementations you might need for different hosting models. So if I'm going to go back over here, all right, you'll see in the shared homepage, that's where we were using that. You'll see that we're just saying get form factor, and we're injecting this interface iForm factor, and it's all it does is it just right here declares these two methods here. Okay, get the form factor and get the platform. So the Razor class library has no idea like the implementation. It's just calling the interface. The implementations are here and here. Okay, in either the web app just says I'm on the web, and it just returns the operating system. Okay, in the case of MAUI, it's handling, oops, not that one, this one, form factor. It's handling all 4 different device platforms using the MAUI abstraction layer. In this case, device info is one of the APIs, and I'm just saying, get me the idiom. If it's a desktop, if it's a phone, right? What's the platform? It's WinUI, it's Android, and what version am I running? Okay, so this is just a very simple example of using the MAUI abstraction layer to write your code once and target those multiple platforms. Okay, the way that I hinted over here, the way that we're injecting that is in here. Okay, so we need to add basically inject the interface here and tell it which surface we're using. Same exact pattern here on the web server side. Okay, so that's a really quick thing. I just wanted to show like how to just get started. We have a solution template for you to really get started. Now I want to flip over to like I think was a little bit more real world app that I have here. So I'm going to close that, and yep, thank you. And this one here, let me just run it. I will run the web and the Windows version. So let's get this one started. So this is a little bit more meaty. It has, it's still only 3 projects, but it has a lot more Razor pages. It's using Entity Framework to connect to a SQL Server database and pull up data. It's actually an application that I promised my husband I would write for him for a very long time. It's basically, we call it Home Asset Management System. And what it does is, I gotta start the web app here real quick. What it does is it just basically tracks assets and your maintenance that may be due in your house. Okay, so here's the web version. Here is the Windows version here. This is my assets, is maintenance due here. Okay, so the web app here is just literally, using Entity Framework directly against SQL Server database to pull up the data. In the case of the client apps, they're calling endpoints. Okay, so different implementations for getting these services, but the interfaces are all the same. And so you'll see in the case of mouse and keyboard, we've got, just a grid. This is the quick grid. You can get into a maintenance log, that sort of thing. Almost same exact functionality you have here on the web application. Now, I do have the phone here. Let me get that kind of running here. So let me mirror the screen. There we go. All right, let me open it up on the phone. Now you'll see this running on the phone. Let's see, we got that. Okay, so hold on. I basically have to get this thing so it'll connect. 1 second. This one, here we go. I need to do this and this, I think. Okay. All right. I got this connected here, so it's in developer mode. So when you connect your devices to your computer, hopefully, there we go. Here it comes up. Visual Studio will automatically recognize this as a target device. Okay, so I just have to just do a little reverse proxy to get it to communicate with the web server. A little trick. All right. All right. So now you see. All right. What did I want to point out here? You'll see the difference. Let me get that out of the way. You'll see the difference on the phone, right? We need a different kind of UI. A grid would not make sense in here. This would be this. We want to scroll. We have a card view instead, right? So when I click into the maintenance, you'll see it's a responsive design, right? It's still the same sort of screens here, but I just want to make sure that I'm showing a grid for more of the mouse and keyboard. And it's vertical, right? But it looks basically the same when it comes down to the screens. But this is the same exact Blazor class library. All right. So how do we know like whether or not to show a card view for this in the case of a mobile device, or a grid in the case of a mouse and keyboard? All right. So there's some tricks we do here. All right. So let me go back to this. All right. A couple things I want to point out. Once I inject, like in this case, the maintenance log, the home screen, maintenance log service. As I mentioned, the MAUI app calls an endpoint, and the Blazor app calls just the repository directly. In the case of showing different UI, I can actually multi-target the Blazor class library itself, and then just use compiler directives to show different UI. Okay, so in the case of iOS and Android, I want to show the card views. In the case of anything else, which happens to just be web or Windows or Mac Catalyst, just show the grid. Okay. Now, in order to do that, we go to the project file, okay, of our shared Blazor class library, and instead of just one target framework, .NET 10, I'm targeting .NET 10 for the web, and then all the device platforms that I want. Okay. And so in that way, what happens when we build our MAUI app, the Blazor class library will build for each platform as well. Okay. And so that's how we do that. Cool. All right. So that's the multi-targeting. And then there's also, I should have showed this. Here we go. Let me do this. Go back over here. So you'll see in the case, so we have pictures here. Okay. So there's like a bunch of pictures. This manages a bunch of pictures. So the idea is like my husband's walking around. Oh, I have to start the web app. My husband's walking around the house or outside of the house, and he needs to take a bunch of photos, and he's going to be adding maintenance logs. Maybe this is just a dream to like actually have my husband finish projects in the house, but this is supposed to be like a glorified honey-do list, you could probably say. All right, let me get this so I can get it reloaded. I just have to start the web app. All right, let me just start it over here. Okay, so there is one part of the UI I wanted to show that's very different depending on if you're on a mobile app or you're on the desktop. So in the case of the pictures, when you're on a phone, you kind of want to use the phone to take a picture. So you'll see this take photo button here. In the case of the web app, we're just on the web app, so we can see the pictures, and we can add pictures, and we can upload pictures right, from the file system, but we don't. Yeah, Laurent, do you have a question? You're
no. I'm just confirming that it makes a different UI. Yeah.
Enjoyfulness. Okay, I got it. Okay, so I'm gonna.
Yes, exactly. I'm just excited.
You're like, okay. So all right, I'm gonna actually take a photo though. Like, so I don't know. It's kind of dark in here. There we go. I'm just going to take a photo real quick. So you'll see that what I did is I'm using the MAUI abstraction layer to actually do things that a phone naturally does, right? Okay, so now I've got the photo. All right, so if we look at the code over here for that, I am basically just saying if Android or iOS, add the photo button, okay? And I'm injecting this photo service. So the photo service over here, in the case of MAUI, is just using the media picker. And the media picker API will handle taking photos across all of these devices. Technically, it would still work on Windows as well. If you had the webcam permission available, it would do that as well. Okay, so this is just an easy way to access device specific things and use the MAUI abstraction layer. The other thing I wanted to point out here is that you'll notice that if I don't have a picture for an asset or something, I display like, oh, hold on. Oops, go back. I display like a default image. Let's see, like maintenance logs and things like that. Yeah. So see if we didn't take a picture, there's just like a default image. Now, like that could just be extra data on the wire down to a client. And if it's always the same picture over and over, why would we want to send that down the wire, right? If it's the same picture. So in the case of, like I mentioned, we can control the web view a little bit more deeply. Okay, now. So remember the main page has this Blazor web view here. Okay, if we look at the XAML code behind, we now enabled more methods for intercepting web requests. And this is a .NET 10 feature now. Okay, so you can do anything you want to this web view. What it's going to do is it's going to fire this event anytime it's trying to download something, like get a resource, right? Right. So in this case, I'm just saying, hey, is this the default placeholder URL? Okay, and instead of downloading it, instead, I stuck it right in here into the raw folder. Now everything in this raw folder just goes right onto the device, right onto disk. Okay, so then what I'm just saying is like, hey, just load it from disk, from the app package. Okay, and so this is a very Mauiism, but what it's doing is it's just saving a lot of data on the wire. And this is just an example. You could pretty much do anything you want. Intercept, you could change the headers, you could do all kinds of things. This is sort of just to enable a bunch of scenarios for you.
That's really cool. Yeah.
Yeah.
I love the new term Mauiism. So this is a new term, right?
The last thing I did want to show you, it's pretty cool.
Very quickly, because we're almost at the end, and we have a question actually. So, but just go ahead. No, you're okay.
Well, because Ed asked earlier, and I can chat with an assistant about these assets, right? So, what would be a good maintenance plan for this asset? Okay, so here you go. To provide well-tailored, so this is basically using AI. So yes, you can AI all of the things, and also like multimodal apps and that sort of things are really important to think through on mobile devices. You have a lot of things you can do there. So sorry I went over.
Also for diversity and integration, where it's important to also cater to people who maybe cannot type or cannot see so well, or I have my reading glasses now. No, this is really cool, yeah. And I do like the hybrid aspect, and really the fact that you can build multi-platform applications like that. There was one quick question from AC. And AC is asking if the Fluent UI Blazor library that we saw just before is also working with the with MAUI applications.
Yeah, there is Fluent for a Blazor hybrid, I believe. Correct.
Okay. Very cool. Very cool. All right. Well, thank you so much, Beth. It was amazing as usual. Okay. So definitely appreciate your time coming here, and hopefully I will see you in November at Ignite.
Thank you. Talk to you guys later.
All right. Talk to you soon. Bye. All right. So we are almost done. One more session. We are going to welcome Jimmy Engström from Sweden just after the break. Next session, we have Jimmy. Jimmy, welcome to the show. And you are based in Sweden, right? How are you doing, my friend?
I'm doing good. And yes, I am based in Sweden, and it's getting cold.
Yeah, it's getting cold pretty much everywhere, in Switzerland too. People will notice that I'm wearing different clothes. It's because, Jimmy, you are recording your session. And I'm wondering, how's the market in Sweden right now with Blazor? Are you doing a lot of Blazor work?
Well, for me, I'm doing only Blazor work at this point. I'm doing some consulting. I'm talking to companies that want to move to Blazor and stuff like that. And for the company that I work at, we have basically two allowed technologies, which is Angular and Blazor. And my team is doing everything in Blazor. As for the market, I'm seeing a lot of requests. I'm getting requests on LinkedIn and messages of people that want to learn new things, learning new Blazor stuff. So I'm seeing a very large increasement in people that want to learn Blazor. Same with my courses. I'm seeing like my getting started course is one of the top 5 on Dome Train every single month. So it's really, really exciting times.
Well, that's fantastic. And you're well known in the Blazor community, so we're excited to see what you prepared for us. Thank you so much for being part of the show, and take it on.
.NET 10 is about to get released. And in this talk, we're going to talk about what's new with Blazor and .NET 10. There are a lot of improvements, and there are some major ones in there. My name is Jim Engström. I'm a lead developer at a company called Cab Group here in Sweden. I'm a Microsoft MVP for 11 years now, and I've been running Blazor in production since its release back in 2019. I'm the co-host of Coding After Work podcast, a Twitch and YouTube channel, podcast, and we do all the fun stuff over there. So please check that out if you want to know more about that. I've written a book, this book, this book, and this book. And these are the only Blazor books with raccoons on the cover, which is obviously the most important part. I've also done a couple of courses over on Dome Train, a getting started one, a deep dive, and an authentication course as well. But enough about me. Let's talk about what's new with .NET 10. Now, this is not a .NET 10 specific feature. It's actually a Visual Studio 2026 feature. Microsoft is introducing the Rosling co-host server, and this is a really big deal for Razer and Blazor developer. Up until now, Razer had its own compiler, completely separate from Roslyn. That could sometimes cause inconsistencies. Razer and Roslyn might not agree on the state of your code, leading to, well, broken IntelliSense and some strange errors. With the new co-host server, Razer now runs directly on the same Roslyn engine that powers C#. This makes editing much faster, more reliable, and even reduces memory usage because Visual Studio no longer has to duplicate work. Another big improvement is hot reload. I know, right? We all waited for this one. With this change, hot reload now support more so-called rude edits. Edits that previously would have to force a stop and a restart of the application. And now, if you make a change that can't be applied, you can make Visual Studio automatically restart your application if that happens. Now, the crazy part is that it doesn't end there. The Razer editor in Visual Studio is getting a lot of improvements, both in features and, of course, in performance. And there's so much more. But this is not a Visual Studio talk, so I'm going to stop there and continue with some Blazor stuff instead. First, let's talk about the new template, because there's a lot of stuff happening in the new template. So let's take a look at that. So here we have Visual Studio 2026 and a new project and, well, the new template. So let's have a look. I'm going to take a couple of minutes just to talk about Aspire, because Aspire is such an improvement when developing Blazor applications or any ASP.NET applications. So basically what we will get is we will get 2 projects, an app host and a service default project. The service default project contains all the things that you would share across different projects. So if you just jump into extensions here, we can see that it setups open telemetry, health checks, service discovery, and all of these goodness. So we're gonna get a very nice setup just out of the box. We also have app host project. And the app host project is what holds everything together. Now, in this example, we have one project. We only have the NET 10 demo. So let's take a look at the template. The template is a web app template. And if we jump in here, we have the client. We have a couple of components, services, and stuff like that. I moved things around a little bit for this demo, but this is generally what you get. We also have the backend project or the server project that will handle all the pre-rendering and stuff like that. So let's jump into our components here and our app.razor, because here we got some really nice improvements. So let's have a look what we got here. First of all, we have the resource preloader, and this will make Blazor apps loads faster. It tells the browser up front which resources are important, like scripts, styles, WebAssembly files, and stuff like that. So it can preload that content. You have the import maps, and it just don't map script locations. It also handles fingerprinting and stuff like that. So you get this kind of a benefit of a clean and simple import while also getting a better cache busting and reliability. Cool. Then we can scroll down here. We have the reconnect modal, and we're going to come back to that in just a bit. And then down here, we have @assets for the Blazor Web.js. So the Blazor Web.js will also be fingerprinted, and it can be cached for a longer period of time. Nice. So let's take a moment to take a look at the reconnect modal. The reconnect modal is in here, and it contains all the things that we need for the reconnection dialog or the reconnect modal. So this was previously very hard to change. And I remember back in the day, we need this in Swedish instead, so I needed to translate everything. But with .NET 10, we have access to it like this, so much easier to edit and use. And if we take a look in here, we see that we also have a JavaScript that contains all the logic for reconnecting. So here we can see everything that is happening and adapt if we want to. Now let's jump into routes, because here's something new as well. If you scroll over here, we can now see that we have a not found page. So we have a page that would handle the not found circumstances. So we can jump into pages here and find our not found page. So we can have that as a separate page, which is really nice separation. When it comes to fingerprinting, that also applies to WebAssembly project. So this is a WebAssembly project, and we can jump into the www root, our index.html. And as you can see down here, we have the syntax that will be replaced once we build this project and start everything up. So the fingerprinting is also available with WebAssembly. A very common question I get is, how do I set up authentication and authorization? And it has been a little bit of a hassle, to be honest. It has been hard to find resources. Heck, I did a whole course on this. In .NET 10, Microsoft is focusing on making it easier. Easier to build secure apps with ASP.NET Core. Now this includes support for passwordless authentication with WebAuthn and passkeys. Now this is included in the identity template for Blazor. So just pick individual accounts and you'll be set up for passkeys. Microsoft is also improving the way the developers set up authentication with new scaffold. So these tools will make it possible to add identity, Enter ID, hybrid auth, all of that stuff into existing apps. They're also making sure that you have a great documentation on these topics. So let's quickly set one of these projects up. So let's go to File, New Project. We're going to go for a Blazor web app. Let's call it Auth Demo. And let's create it into this solution like that. We want .NET 10, of course, individual accounts. We want to run, well, let's run server for now. That's totally fine. Let's go with a global interactivity location and also enlist with Aspire. So let's create this. Awesome, we're up and running. So let's run Aspire. There we go. So we got both of our demos here running at the same time. Really nice. And we have all of this other stuff here. We're going to come back to all of that. So I'm just going to leave that for now. Now let's jump into our auth demo here. So let's open that one up. Here we go. Let's register an account. And let's just click here to confirm my account. There we go. Perfect. We have an account. So let's go to login. Here we go. And now I can jump into my profile here and I can set up passkeys. So let's add a new passkey. Actually ask me to do a pin. Let's do that. And passkey saved. So let's click OK. And let's give it a name. Let's give it Edge, because this is saved inside of Edge. So there we go. So great. Now let's log out. And now let's use our passkey instead. There we go. I want to use this one, please. Let's do that. Let's add our pin here. And boom, we are logged in. So we get all of these really nice features. And since this is a feature of ASP.NET, we're getting it inside of Blazor as well. Now, we also get a lot of new ways to understand what is going on inside of our Blazor apps. They've added new metrics, including Kestrel memory pool, authentication and authorization, and Blazor-specific metrics. This gives us a much better insight into how your application is performing and where resources are being used. They've also added some activities to Blazor server for distributed tracing. Really nice stuff. I never thought I would be as excited for observability and diagnostics, to be honest. So that means that now we can trace things like page navigations, UI events, and that all the way through our system. Now, on top of that, there are some new diagnostics for Blazor WebAssembly. You can capture performance profiles and memory dumps, which makes finding and fixing issues a whole lot easier. So let's jump into our Aspire project here. Our service default and extensions here. I'm going to replace this chunk of code real quickly here. We're going to add a couple of meters here. So components, circuits, lifecycle, authentication and authorization, memory pool, all of these different things. And let's run our project again here. Let's jump into our author demo. Let's log out. Let's log in again. And let's log in with our passkey here. There we go. I'm going to use that one. Go. And we are logged in. Awesome. Now, let's jump back here and we can take a look at metrics here. And if we go into our auth demo here, we can see authentication here. And we can see the duration of authentication, how many sign-ins has happened. And we have all of these different metrics that we can take a look at. If we take a look down here, we can see circuits active. We have one active circuit. So if we copy this one and we open up another one, we should now have two of them. So we have all these nice metrics that is just going to be included out of the box in .NET 10. And we can also see here in traces that we have a lot more information that we used to have. We can go into and see even more data here. There's a lot of stuff, again, just there out of the box, which is really, really nice. And if you haven't tried Aspire yet, all of this stuff, you get this portal, you can see all the traces, you can see all the stuff happening, has been such a time saver for us. It's just simply amazing. And we found things that we might never have found. Like, for example, there was a call we did twice to get data instead of caching it and stuff like that. So this is super convenient. You should definitely check out Aspire if you haven't done so yet. Now, next up, we're going to talk about WebAssembly diagnostics because we're going to get a lot of stuff there as well. Now, let's just jump back to my computer and take a look. So this is a WebAssembly project, and you need to do a couple of things to get everything working. So these metrics are inside of the web browser. We need to add a couple of things. We need to add all of these lines. And this basically enables the WebAssembly profiles inside of the web browser. So let's start this project up and let's run it. There we go. And let's jump into our developer tools. Let's jump into performance and let's press record. So let's go in here. Let's go to counter. Let's click around a little bit. Let's move to weather, something like that. And let's stop the profiling. There we go. So here we have all of this really cool data. This down a little bit. Scroll in here. Let's see if we can find something cool. So here we can see all the things that are happening inside of our web browser, all this profiling. I honestly have no idea what all of this means. But what I do understand is that we get all of this diagnostics really simple and accessible inside of the web browser. But it doesn't end there. We can do even more stuff. So I'm going to switch project. This is also a WebAssembly project. And I've added a couple of things in this project as well. So it looks fairly similar, but it's not. There's different tags here. This enables diagnostics so that we can run a JavaScript that starts collecting metrics into a file that we then can use inside of Visual Studio. So let's take a look at that as well. So let's jump into our dev tools again. Let's go to our console here. Let's paste a little bit here. So global this, get .NET runtime and collect CPU samples and do that for 5 seconds. That's what we're saying. So let's do that. Let's jump in here. Let's do some clicking around. It's done. It is downloaded, I believe. There we go. Look at that. Now let's jump into that folder and simply drag this to Visual Studio. And it's going to open this file up here. As you can see, we have all of these diagnostics that you can take a look at, see what is actually happening here. Now that was CPU cycles. We can do the same for collecting metrics. So let's do 5 seconds for that as well. Let's click around just a little bit here. Let's navigate, do some stuff here. There we go. We got another one. Let's go back to Visual Studio here and let's grab that one as well and take a look at that. And there we go. We have some other metrics so we can take a look at what is actually happening inside of our applications. And we also got one more, and it's this one, which is collecting a GC dump, so a memory dump. So we can do that and we will get that here as well. Now we need to convert this file to be able to open it in Visual Studio, but I'm not going to do that for this demo. Just know that you can also analyze memory dumps, which is super cool. And now, my friends, we have reached the last demo. And I would argue that if this was the only feature coming for Blazor in .NET 10, which you have seen it's not, that would be enough. Because this is such a great feature. In .NET 8, Blazor introduced new render modes, opening up for some really amazing user experiences. Basically, removing many of the previous arguments when it comes to load time. But it also opened up a lot of questions. This was a model not everyone was used to, and suddenly there were some new challenges. This is one of the most common questions I get. Why is my content loading twice? Now this is simply because the content is pre-rendering by default if you're using the web app template on the server. And when SignalR or WebAssembly takes over, there's no automatic transfer of the state between the two. So we had to add a couple of lines, and I'll show you that in a bit, to get all of that up and running, to get that transfer smoothly from pre-rendered to WebAssembly or SignalR. And we had to add it in a lot of places. This transfer state was only relevant for the first load, because after that, everything is running either as SignalR or as WebAssembly. So it was quite a high cost of adding this code everywhere. So a lot of people ended up just removing pre-rendered, turning it off. But I think that the pre-rendering especially for WebAssembly, is such an important change for Blazor. It's not only about loading speeds, it's about SEOs. And frankly, most front-end frameworks are moving towards server pre-rendering right now. So let's take a look at the problem first. We have our NET 10 demo here. So let's take a look at our app.razor here. And we can see that we are currently running interactive server. Let's actually change that to interactive WebAssembly. Now, if you haven't worked with this before, you see how easy it is to go from server rendered to WebAssembly rendered. It's just that line of code. So let's zoom in just a little bit and let's go to weather. This works fine. So if I reload this page, you can see that it's static and then it switches over to WebAssembly. This is the problem. If you take a look at the data down here and I reload it, it's static coming from the server and then it reloads. And since the data is random in this case, it's very visible that it's glitches. So we need to fix this. So let's jump back to Visual Studio here and to our client project here. We have components, pages, and I have a bunch of different weather files here. Now I cleaned this up just a little bit. So in the weather 2 example here, I'm using the iWeather service, which is doing the same thing with the random data, but it also has a parameter, which is for how long it should wait. So in this case, it's waiting for 3 seconds. And if you scroll up here, you also notice that stream rendering is not turned on. So let's pop back to our browser and let's go for weather 2 instead. And as you can see here, it takes 3 seconds before we're getting content on the screen. Then it's pre-rendered, it's going to switch over to WebAssembly, and then it's going to wait some more. So I'm going to show you that once again. So I'm pressing the button now. It's waiting 1, 2, 3. We're getting the data and it's now waiting 3 seconds again. So that's the benefit of stream rendering. And the cool thing is that we can combine this. I don't see enough people talking about the combination of the two. Because what we can do now is that we can go back here and we can take a look at the third example. And the third example is the same as the second example, but with stream rendering on. Go to home, go to 3 instead, and take a look at that. We're getting response straight away because it's streaming the response. It's still waiting 3 seconds before we're getting some data. Let's see it again. Boom, waiting 3 seconds, but it's getting the data on the screen straight away. And then switches over to WebAssembly. Such a huge difference. And then we have a fourth example here. And this is implementing the persistent component state that we had earlier. That it's not the .NET 10 one. So here we're using a persistent component state. We're still using streaming rendering. And if we scroll down here, you can see that there's a lot of code just to set up the persistent component state here. So all of this code, except for line 52, is just to set up the persistent state. And it continues down here as well. So there's a lot of code that we had to write to get this up and running. So let's jump into weather 5. We still got the service, we still got stream rendering. And if we scroll down here, we have a property of weather forecasts, and we're loading forecasts down here. No state handling so far. We need to do 2 things to get this working. The first thing we need to do is to add an attribute persistent state, like that. And then down here, we need to check whether or not this is null. And if it is, don't do anything. But if it is, then load the data. So what is going to happen, the server is going to pre-render the content and store that content in the DOM. And then when WebAssembly or SignalR kicks in, it's going to check, hey, do I have a state? Hey, I do have a state, and can pick that up and use it. So let's take a look at what that looks like. So let's go to weather. I'm going to load weather 5. So I'm pressing enter now. You see, fast. It's waiting 3 seconds, but we got the stream rendering pushing over the content. I don't have any content. It's giving me the content. And then when WebAssembly takes over, the data is already there. So let's take a look at that once more. Fast, static, loading the content, waiting 3 seconds, boom, static, over to WebAssembly, and the data is still intact. The biggest argument against WebAssembly is the load time. Let's reload this once more. Boom, we have content on the screen. It's static, it's WebAssembly. We have all of that really fast loading. And the only thing we had to do to get all of that working was 1 attribute and 2 question marks. I know. the cool thing here is that this works for Blazor Server as well. What usually happens when we're talking about Blazor Server is that if a SignalR circuit gets disconnected, it's going to stay on the server for 3 minutes and then it's going to be flushed away. So we're not going to care about that anymore. Previously, it's been a little bit tricky to get back to that circuit. But now, first of all, that works much better, but we can also use the persistent state to persist data that we want to keep, even though the connection is turned off. What we're going to do is we're going to jump into our program here, and where we are adding interactive server components, we're going to say that disconnected circuits, we're max going to retain no one. So as soon as we would disconnect, the data would be gone. So let's see if that's true. Now let's go to the counter and let's click just a little bit. Let's go to our console. And in this case, we're going to use blazor.internal force close connection. So we're closing the SignalR connection. And look at that, failed to resume the session. Please reload the page because we're not retaining the connection anymore. So if I reload the page, well, we see that the state is gone, of course. Now what happens if I go into my solution here, go to my counter, and I'm going to say, you know what? I think that this content is important. I want to keep that state. Even though you're terminating the connection, I want to keep that state. So let's save this. So let's go to the counter here. Let's click away just a little bit here. And let's run the force close connection. Boom. And you see we are getting the connection back and we're still keeping the state. Really cool stuff. So now suddenly Blazor Server is kind of a contender because we can keep the state even though we get some problems with the connection, with the SignalR connection. Another challenge with Blazor Server has been that it's keeping these connections all the time to the server. So if I go and do something else on my phone or on my laptop, I don't want to have that SignalR connection connected all the time. So that's where some new APIs for pause and resume comes in. So we can add a little bit piece of code here. So we're checking the values or the event visible change. And if the document is hidden, in that case, we're going to pause the circuit. We're going to turn it off. And as soon as the page is visible again, we're going to resume the circuit. So in the end here, we are not only resuming if we are moving back to that tab or to that browser, but we're also disconnecting if we're not actively using the site. We are freeing up resources on the server. And if there are stuff that is important, we can use the persistent state. So let's jump back to our site here. Let's jump into our metrics. Let's check out Net 10 demo. And let's take a look at active circuits. So we currently have one active circuit. Now I'm going to navigate away. I'm going to use another tab. In this case, we're going to the .NET site. And as you can see, we are now down to 0 circuit. Now let's go back to the site and boom, we are now active again. These are some really, really nice APIs for us. And as I mentioned before, suddenly Blazor Server is a contender because we don't need to allocate all those resources on the server. We don't need to have active SignalR connections at all times. If we don't need a connection, we can turn it off and we can resume it when we want to. Whew. Well, we talked about a lot of awesome stuff today. We got more reliable and faster hot reload. We got better IntelliSense. We got faster loading. We got metrics, observability, simpler testing, security improvement with scaffolding, state persistence, both for preload, handover, and of course with SignalR or Blazor Server. And of course, more possibilities when it comes to handling Blazor SignalR connections. So thank you so much for listening. I hope you are as excited for .NET 10 as I am. And if you have any questions, please reach out and I will try to answer them as best as I can.
All right. Thank you so much, Jimmy. It was great to have you. You may have noticed that it was a recording because Jimmy was busy somewhere else. But nonetheless, he wanted to take the time to share the knowledge with you. And as you could see, it was really packed with information. So this is great. Thank you, Jimmy. And Jimmy, also, we saw you in the chat. So thank you so much for answering the questions. So we are at the end of BlazorDay. It was the last session. Hard to believe that we had 5 hours of session. It was really packed. Let's bring back Dan. Dan, thank you so much for joining us again. You opened and now you do the closing. It's only appropriate, right? How did you like the day?
It was fantastic. Fantastic content. Great speakers all around. I mean, I've got a lot of stuff that I'm going to be reviewing and learning from. I love the vibe coding with Blazor and adding AI features to your apps, like super cool stuff. Great job, everyone.
Yeah. No, this is great. Yeah, I also learned a lot of things, and I have tons of things to go and check again, because, by the way, the session, even though it was live, the session was recorded. So if you go back to the reactors page on YouTube and then you check the same page, you will get to see the recording immediately. So this is really cool. So Dan, let's close up with a few musings, if I should say so. I hear that you started already the planning for vNext, so that would be .NET 11, I guess, or whatever we call it. I think it's 11, probably.
You want to talk about 11? We haven't even finished shipping 10 yet. Like, it's still.
I know, but you know us, right? We always want more. So.
It is true, though. We are starting to think about the next version. .NET 10 is, wrapping up. We've already shipped the first release candidate, so that's out, and you can deploy that into production and try it out with your live systems and send us issues, and we're addressing those. We expect to ship one more release candidate next month, like in October. We'll have a follow-on release for what we really think we're going to be shipping in the final release come in November at the release party.
I guess October is next week, right? So you want to hurry up a little bit here.
It's coming up. It's coming up fast. So yeah, like if you have any feedback on .NET 10, please let us know. Try out the bits, download Visual Studio 2026, and give the whole tooling experience a try. Jimmy talked about some of the great tooling experience improvements that are coming in that release, like hot reload and better Razor editing. Those are all things that are still being worked on. So give us feedback on those things. But yeah, the team now is starting to ramp off of .NET 10 work and move on to thinking about what should we do next? What's the next stage for not just Blazor, but all of ASP.NET Core, the entire .NET platform. There's not a ready to go roadmap yet, but what I would say is that now is the time for the folks in the Blazor community to engage with us. Like start talking with us about things that you think we should be doing in the next release. Come to us.
Well, how can people do that actually?
Quite a lot. We have one of my favorite things actually is doing the release notes for each of our preview releases for a .NET release. And as part of that, we go through and list all of the contributors that actually have contributed, code and features and code fixes into each of those releases. And I get to list them all out and thank them. And it's amazing how many people actually, spend their time and their effort helping to make the .NET platform better directly, like actually contributing pull requests. So thank you for everyone who did that for .NET 10. We hope to keep working with you on .NET 11. For .NET 11, go to GitHub and start looking at issues and start thinking about suggestions that you might want to make, things that you care about. If there are issues that are already there you care about, give them the thumbs up reactions on GitHub. We look at that and sort things by those reactions. Don't game the system, but give yourself give an honest signal there so that we can continue to use that. And we will start having community discussions through our regular ASP.NET community stand-ups about our planning effort and our current thinking about areas that we want to invest in. And we want to hear your feedback, what you think should come next to the stack.
Right. So really encouraging people to join those communities and to participate in the process, because .NET is developed in the open. And I think it was probably one of the first, if not the first, project to go open source, right, at Microsoft.
It was definitely a leader. Yep.
Definitely
it was pretty fun in the early days.
Yeah, I still remember the days when with Scott Hanselman and other people who did that. So this is really cool to hear. So it's amazing. We're at the end of BlazorDay 2025. So I want to thank our amazing presenters, because we had really 10 fantastic presenters who do this out of the goodness of their heart, right? I mean, there is no pay. I also want, of course, to really thank my colleagues, Denis Voituron from Microsoft, Christophe Peunier, and Adrien Clairbois, who again did the whole planning and the whole thing without compensation. Well, we had pizza, but actually, it was not paid by Microsoft or anything. There's no sponsoring. This is really all out of the volunteer and out of the community. So this is really amazing. Thank you, everyone. We hope it was helpful for you, because this is really the most important for us, is that the sessions that we put out there are actually helping you to achieve more into your project and into everything you do. Don't hesitate to try things out, right? Go back and re-listen if you didn't totally catch something. And most importantly, please always keep learning. Dan, thank you so much for taking time out of your very busy day to help us here. And all the best. Everybody have a very happy Blazor Day, and see you next time. Thank you so much.